Soon? Hello? 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 Am I live? I think I'm live now? Yes, okay. I think I'm live now on YouTube. Sorry about that. Hey everyone, how are you guys doing? So yesterday on YouTube, I put out a video entitled just "My Heart Broke," talking about my issues I've had over the past 3 or 4 months, dealing with the myopericarditis thing, and all that is true. Like my heart is still like recovering, but it's recovering at a point now where I feel I can probably get back into making content. I have a heart rate monitor. I don't know if you guys can see it there. It's like for exercise and stuff. But look, I mean, the heart's at like 82, 83 right now. I think as long as I'm sitting, and maybe even if I'm standing, things are probably fine. It's just if I, do things a little bit too crazy, I just have to kind of keep my heart rate down. That's it. That's what I have to do right now. I'm technically, it's been 3 months since I've been out of the hospital, so I should be able to do like most things. But I'm not at the stage yet where I'm like able to, it's going to be at least 3 months before I'm allowed to go to the gym or something like this. But at least for now, I should be able to get back to work, right? I should have technically been able to get back to work for the past few months. But if you've noticed, I have kind of like a new streaming setup. I don't know maybe nobody noticed or cared, but here's basically what happened. So we live in a 2-bedroom apartment with 2 children, and I was using 1 bedroom for the office, which doesn't work anymore for just one of my kids wanted their own room. That's totally fine. They're 3 years old. They want their own room. I totally get it. And so we rearranged my office into a bedroom for them, and then I had to move my space into what is essentially the living room. It's like kind of a cubby area. It's like a basement area that's downstairs, but it's kind of connected to the living room via a stairwell, which I could show you, I guess, if I don't know if you guys probably can't see it. Anyway, point is, like, there's a stairwell back there that kind of connects me upstairs. And so, like, I'm in a box, but it's not a good box. It's just like a fabric sheet that I'm using as a way to do some mild soundproofing. I'm hoping it works okay. I don't know. I have no idea how any of this is going to go. So let me just kind of go around really quick, see if I can find a particular, I think this is what I'm looking for. Oh, I think I found it too. There we go. I'm going to put some background music on. I think that will be fine. I don't know if you guys can even hear it. It's probably too quiet. My whole stream setup is like really messed up. I don't really have like clear goals for today's stream either. I just want to kind of pop in and say hi. How's everyone doing? Logesh in YouTube chat. Hey, Siren Alderoth and Ekshonyum. Hey, how are you guys doing? Right, so lots of little things to talk about. Let's go ahead and jump into it. And obviously like my YouTube stream or whatever, you can't hear it. Oh, you can hear the background music. Oh, okay. I can increase it a little bit. I think I usually keep it around here or something. I don't know. It's not supposed to be like super loud. It's just supposed to be in the background. Anyway, look, lots of stuff to talk about. So let's just go ahead and hop into it. I don't know where to start. So let me do this. Let me go there and let me open up a new Zernal PP shell. Zernal PP, and let's just kind of, in the traditional Laos Labs fashion, let's just kind of write it all out. Look how big my mouse. Why is my mouse so big? I don't know. Okay, so. As of the stream, as of the video I put out yesterday talking about my heart broke, I had kind of like a couple things that I talked about. I said that I wanted to do open, that's black on black. I obviously need white or something. All right, so do open research. That's kind of one thing that I said I wanted to do, right? And it is something that I do want to do, right? I feel like the music's too loud. I don't know what you guys are hearing, but I'm gonna drop it down just a hair, something like that. Okay, so long story short, what does this mean, right? Well, I'll go and show you some stuff that I've been working on. And I have a lot of ideas of what I want to do, but I also want to hear what you guys want to do. The idea here has kind of changed a lot, like when I was sitting there in the hospital, I was told I had a 1 in 4 chance of heart failure, and my brain went to weird spots, and I started realizing that, like, I had this goal in my head of what an open research lab should look like and how this type of thing should go. And I realized it doesn't have to go that way, right? Like, I don't have to be in charge of the lab as it is. I don't have to like hire people and like build a company and scale up. All I have to do is make sure I'm funded, and then any excess funding that I may or may not receive can go in the form of grants to other people doing research in a similar fashion, right? And in that way, I'm not really building like a big company that does everything. I'm building the scene in the same way that you can like, grow multiple people. Like basically, I just want more people showing how to do like science publicly. Like in my mind, what I really wanted to do, oh, those are my channel analytics. I don't know if I'm allowed to show those, but there they are. Twitch.tv. One thing that I've always wanted to do, where did it go? There it is. Hello. I don't know who this person is, and I don't know why I'm following them. Okay, so let me go over here. So what I want to happen is I want people to be able to go to Twitch and to scroll down and immediately be able to find the science and tech category. And I want people to be able to go to the science and tech category. See, here we even have to search for it because it's not in the IRL section. So go to the science and tech category. And I want to be able to say, like, look, you go here, and you're going to find interesting people talking about interesting things. That's what I want to be able to say, right? And I can't say that right now because as it is right now, it's the Artemis 2 stuff, which, don't get me wrong, is very interesting and worth people's time. But once Artemis 2 leaves, there's nothing in this category. No one's doing research. No one's, like 5-10 years ago, when I was like starting out on Twitch, there were a whole bunch of people who were doing research on Twitch. They were like, doing climate simulations, molecular dynamic simulations, fluid simulations. I remember distinctly watching these people. There were people who were like looking through things in a microscope. There were so many people doing so many things, and that has not happened at all in the past few years. So in my mind, I would rather build the scene and get more people into doing open research than like just hire a whole bunch of people and kind of keep them in my own company. And so that's like kind of the big mental shift that's happened to me recently. I've realized I don't need to focus on making like the biggest, most interesting like impact and like the best videos for the largest number of people onto my channel. The difference is I want more people to do more things, right? And I want them to have their own initiative and kind of do their own stuff. And so for that reason, I kind of want to be the guy who's kind of doing my own thing. And I want to be part of that change, if that makes sense, right? It's too loud. This is too quiet. It is what it is. Must have been the wind. If there's one research I really want to do, it's chemistry. I love tactile experience with chemistry experiment. Yeah, tell me more about that, Hanif. By the way, thanks for the message or the... Okay, as of the last video I put out, there was like a little bit in that video that said, if you have ideas for some research that you want to do that could use my expertise, feel free to just like send a message somewhere. On Discord or via Google form. And a few people did send messages via Google form. And I've got a couple of really interesting projects that have maybe come from that. The issue is that I've got to figure out, I know this sounds really stupid, but not only do I have to make it interesting research-wise, which I think is usually quite easy to do for me, but I also have to make it interesting content-wise, and I just need to think about like the right framing for a lot of this, Okay, let's see, what do we have here? How are you feeling? I'm doing better than I was, right? I showed my heart rate monitor. It's like 80s or something like this. I don't know if you guys can read it or not, but it's fine. I'm doing okay. That's a giant jacket you're inside of. It is a giant jacket I'm inside of. I'm in a giant box. That's what I'm doing. GPU, of course. Okay, so where do we go from here? Let's go ahead and show some of the stuff that I've been working on and talk about where that's going to go. And then, honestly, I know this sounds kind of stupid, but I kind of want to do an archive for all. Just kind of go through all the papers on the archive today and just kind of like refresh like kind of what's going on in the research scene and all this kind of stuff. I used to do this like every day and I loved it. And I think it's probably a really easy thing for me to do, just to pop in, try a new stream, and just kind of like get used to the feeling of being live in front of an audience again. Because like, it's been a while. It has been a while. I'm a little bit rusty. So first, what I've been working on: CD projects, papers, SIGGRAPH. Okay, so here's the thing. The SIGGRAPH deadline was January 15th or January 22nd, because the 15th was when you had to tell them that you were going to put a paper forward. I was really, really close to getting a paper ready to go for this year's SIGGRAPH of 2026. I know it says 2025. That's because I started working on it in 2025. That didn't happen because I was in the hospital for January, and it's been 3 months, and so I haven't been able to work on this. But it is something that I'm very passionate about, and I want to push through. So let me just go and showcase where I'm at. So let me go into ocular main.pdf. Right, so I've been working on this method for composable function systems as a general purpose rendering framework. Okay, so I have been really... I talked about this a lot on my stream. I've talked about this a lot to a lot of people. I think it's super interesting and cool. The idea is that, like, GPUs, CPUs, any computer, it's got memory and it's got like cores that do things and the memory that holds things. And the problem is with pretty much any computational workflow, it's the memory that's the problem, right? You are spending most of your time sending data back and forth between different memory, between the memory hierarchy, between CPU and GPU, between distributed GPUs, between all these different things, right? So my idea was, let's just kind of like take the memory out of the system entirely, and let's reformulate the way in which we draw object primitives. So instead of them being like, mesh points held in memory somewhere that we then like fragment shade onto the screen, we treat them as function systems, right? In the same way you treat iterative function systems as function systems that can draw a square. So we have an iterative function system that draws a square, and then through an additional set of transformations, you can do whatever the heck you want with that square, right? And one big image that I drew last year, which is a work in progress. It's still a work in progress. This is not the final image I want to put in the paper. But, basically you could draw a single circle, and you could use that circle to draw anything you want. You could draw the comets, the stars, the rings, everything in the planet. Again, this isn't the final rendered image that's going to be in the paper. But the point is that like by drawing a single image via this iterative function system, you've not allocated any data in global memory. Like there's no mesh points, there's nothing like that. You've been able to generate thousands of objects without having to copy anything. Everything is just a set of equations, right? And importantly, by composing these function systems together, you can mess around with the way in which rendering is typically done. Usually you've got like vertex shaders and fragment shaders, and then you render it to screen, and there's a very strict way in which the rendering is done. But in this way, because we give users more control over the way in which they write their function systems, we're able to manipulate this so that users can like put the drawing function in between the rendering cycles and all this kind of stuff. They can kind of mix and mash things, right? And this is kind of like a clear situation where doing proper metaprogramming, where you write this over here, and then it's transformed into a bigger kernel that can do more things over here, allows users more flexibility. They're able to do more things, and there's actually a lot of different things that we could do with this. I'm very excited for like the future of this technology. However, here's the problem. Again, it's memoryless. All this, it's really cool. It's really cool. Do you like my picture? Obviously, it's a work in progress. Man, I can't talk. But the point is, I had a lot of clear goals of where I wanted to go with this. A lot of projects that would be spawned off of this one yet. And I know this sounds stupid. I haven't been able to work on it, and I was planning to get it out for SIGGRAPH this year, but I've just been sick for the past 3-4 months, and I have not been able to get it done. So that's where I am at right now. I would like to be able to keep working on this, and I will keep working on this. But this is probably a next week type of thing. Not today, maybe not over the weekend or anything like that. This is something that I want to do as I start feeling better, and I want to do it with you guys, the community, and stuff like this. How difficult is it to come up with these functions? Can you intuit it, or do you need an external tool to visualize it? Yeah, so this is the problem, right? That is a very good question. A very good question. By the way, I see the YouTube chat. I'm coming back and forth between YouTube and Twitch chat. I'll be there. So this generator function here is an iterative function system. Now I have an article on the algorithm archive. Algorithm. You kidding me? I don't have it saved as a bookmark. I don't have my own website saved as a bookmark. Oh, Jesus. Algorithmarchive.org. Sure, this should do. Okay, so I actually have an article on the algorithm archive already for iterative function systems, right? And this is one way in which you can visualize create the initial object primitive, in this case a square. But you can also do circles and triangles and so many different things with iterative function systems, right? So that's one way to start. But you could also start in a number of different ways. Like, for example, if you do some sort of like LiDAR system, you can essentially do like the Gaussian splatting approach that people are doing nowadays. Like anything you want can start. You don't have to have a complex function system here. And this one is notably very easy, right? X is equal to square root of x squared y squared. So that's just normal r. And then you have a rotation that is dependent on that r. That's it. Like, this is a very simple transformation that you can write in just normal, as you would write normal mathematical operations, right? And that's kind of one of the core purposes of this this engine, as opposed to doing something with like signed distance functions or something like that. When you're doing something with an SDF, the SDF has a core problem, and that problem is that like nobody knows what an SDF is, and nobody knows how to write an SDF, so it ends up becoming very complicated. And as you start doing like smear frames and stuff like that with signed distance functions, again, you can do it all mathematically, but you start to have to like march your arrays through like non-Euclidean space. It ends up becoming a huge pain. And so this is a situation where you can just write in clear mathematics what you want to happen, and you can do anything you want, right? Basically, it's just moving points around in space. So if you're able to imagine how these points can move around in space, you can do that. That's exactly why I showed this visualization here, to show that you can create very simple functions that will do everything you want it to do, right? Anyway, I'm still working on the paper, but this is one of the core things that I want to work on, just on stream and stuff like that. So let me go ahead and catch up on chat, both Twitch and YouTube. Let me move the YouTube chat over here. Chemistry research. Now you've got me wondering if this could spill out into AO3. Wait, what? I should know what AO3 is. What is AO3? My high school does have fully featured lab for high school. There's no chemicals because it's so new. That's fair. Okay, so the other thing I want to talk about before going any further, I know this doesn't come as a surprise to anybody who's ever been on this stream before. I genuinely love the idea of just people who are not researchers doing research. Like, it's super fun. You know, when I was in high school, when I was in junior high, I was reading papers all the time. That's what I was doing. I was reading paper after paper, and I still love reading papers. You know, I said this on like one random stream that I did on Twitch a while ago, but like, you know, when I was like sitting in the hospital, this is like way too existential. I probably shouldn't talk about this, but when I was sitting in the hospital, right? You know, I was, you know, thinking about things and things that I could do to, you know, make an impact in the world, all this kind of stuff. But I also kind of realized I was like a little bit free at that moment, you know, like I could do anything I wanted, like, because I couldn't take care of my kids. I couldn't work. There were so many things I couldn't do, right? And so I thought to myself, well, you know, now is the perfect time to do things that I wouldn't be able to do otherwise. I mean, I couldn't leave the room, but, you know, I could play video games or read books or write stories, all the stuff that I used to love to do. And yet I found myself at that point in time just not wanting to do any of it. I just didn't want to do anything, right? The only thing that could hold my interest was reading papers. That was it. And like dreaming of things that I could do with you guys once I was finally like out of the hospital and I was, you know, healthy enough to start streaming and making content again. That was it. That was the only things that were in my brain. And like, that's why I said in the video yesterday that I'm more motivated than ever now to like start doing research with you guys, because I genuinely want to do it. Like, I cannot explain how much I want to just create or do research in an open way with people and this kind of stuff, right? And my point here is that, like, you know, I've been reading papers since junior high. You know what I mean? Like, I've been reading papers since I as far back as I can remember. And I don't see it as a thing that is necessarily difficult to do. And yet it seems to me, it feels to me like most people kind of, they hide away the research. They kind of put it away so that it's very difficult for people who are like high school level or even undergraduate level to engage with, right? But I don't think that has to be the case. I think if people are just more used to seeing people do research in the wild, that they'll understand how these processes work, and it gives them more motivation to actually pay attention in school. And I don't know, it's just like there's all these good reasons to just showcase the process of doing research in a live and open way, and hopefully get people excited about that process as well. You know, I keep, you know, in my brain, I keep getting into these weird, like, I don't know, troughs. I don't know how to put it. These dips in my brain where I keep thinking to myself, like, no one's going to care. I mean, like, who wants to read this paper on composable function systems as a general purpose rendering framework? Like, this is not interesting to the general population. But then I realized, like, there are people who are literally watching Minecraft right now. Like, there are people watching League of Legends right now. And these are things that, don't get me wrong, like, they can be interesting if you have the right person, but they're not inherently interesting to me in any way, shape, or form, right? Like, I would not naturally want to watch somebody playing Minecraft, but if it is an interesting personality, I could watch that, right? And this is where it's like, I see that. I see gaming as kind of the same as research. Research is super interesting and super fun and super engaging, right? All I have to do is showcase that and to show that, like, you know, there is reason to do this, right? And that's where I'm at, right? What would you say is your target audience? I think in the same way, I don't know how to put this. I would say that my target audience is like anybody. I don't think anybody, I think anybody should be able to watch like videos and stuff and enjoy it. I don't think there should be any like limiting factor there. I understand that sometimes you'll talk about technobabble, right? Like, you know, for example, if a high schooler pops into one of our streams and hears me talking about Gaussian splatting, you know, it might go over their head, but it's going over their head in the same way that, like, someone popping into a League of Legends stream and seeing someone play Oriana or any other character that I don't know about, it's going over their head in the same way that would be going over my head, right? Like, it's I don't think something that is impossible to overcome. It's just a matter of getting that motivation to actually do the thing, you know? And I think the motivation is there, right? Because every time you publish a research paper, you're doing something that has never been done before, right? And the process of doing something that's never been done before is inherently interesting, right? It's just a matter of showcasing that and polishing that off. And so this is why I did like the open call and everything. I want to start to get people in the community to do research together. I don't know what that means. I don't know how that's going to grow in the future. I don't really know anything about it right now. All I know is that I'm trying to find ways to not only like do interesting stuff with interesting people, but to create interesting people within the community, right? I'm rambling way too much now, but like, you know, one thing I loved about being at OIST, and one thing I loved about being in like in university and stuff, is that like when you start talking to researchers, like they can go on and on and on about the most interesting stuff, right? Like basically when I walk into OIST, I could like have a conversation with the person next to me, and I could be fairly confident that that conversation was going to be interesting, right? That is not something I can say about like everybody, you know what I mean? And yet almost every time, like I talk to somebody and I'd ask what they're doing, they're like, well, I'm doing this and this and this, and I ask how you're doing that, and they say, well, I'm aligning the laser to do this, and it's like, well, you're aligning a laser? That's pretty cool, right? Like what does it mean to align this? What does it mean to do that? You know, people would just say stuff as if it's like second nature, like it's boring because it's so routine for them, and yet, you know, if you're coming from the outside, it's quite interesting. It's something that you've never even considered before, right? And so anyway, that's kind of where I'm at. Have you watched the corridor digital video on Gaussian splatting? It's so cool how far the technology is advanced. Yeah. This is also why I'm very happy to see that technology grow. Because it's like, I don't know, we've been on this AI nonsense for so long in the graphics community that I'm happy to see stuff that's not super AI focused. I know there's the nerfs there, which are the reason why Gaussian splatting has become popular. But like this method that I'm proposing here is fundamentally a splatting method. You know, it's just seeing people use it for other things is nice, right? So here's the problem, right? Gaussian splatting is there are two things about Gaussian splatting that are both true. So one is that it's a very simple technique. Literally all it's doing, when you say Gaussian splatting, what are we talking about? We're talking about taking a ball and we're talking about throwing it at the screen, right? That's all we're doing. We're saying, like, for example, let me zoom into this figure right here. This is made of a bunch of pixels, but more accurately, it's made of a point cloud, where we have, let's say, 1 million points in this square. I don't know how many, like a large number of points in this square. And what we're doing is we're taking all these points and we're saying, look, this point is at location X and Y, right? I'm going to find some way to translate that location X and Y to your screen, right? And so it's a splatting technique. It starts at X, Y, and we throw them at the screen, right? That's all we're doing. That's what it's doing, right? And Gaussian splatting is, say, when it hits the screen, instead of drawing on just a single pixel, what it's going to do is it's going to splat out and it's going to create a Gaussian shape. That's all Gaussian splatting is. Now, everything else dealing with neural radiance fields and all that kind of stuff is all about how to create the appropriate point cloud from a series of images that you've taken on from like just a 2D camera. So the idea is that you take multiple reference frames or multiple shots, and you use those shots in order to reconstruct that 3D point cloud. And then from that 3D point cloud, you then throw them onto screen, right? It just so happens that the way to get a point cloud onto screen, the fastest way to do that is via splatting. And because people kind of forgot about splatting until the neural radiance fields came back in, people didn't really care about the method. So now when you say Gaussian splatting, almost everybody knows that you're talking about the neural radiance field stuff, but they are kind of separate, right? And so this is a situation where my specific method is using splatting, but it's not using the neural radiance fields, if that makes sense, right? So this is, I'm not doing the best job describing it. I'm sure other people have a better like description, but this is what I would say for now. And you guys can correct me if I'm wrong. Feynman said something about, if you can't explain it to a layman, then you don't understand it. Is there the best of both worlds where even the children can practice and understand? What do you mean by that? Hey, Loco Padre, Silent Tree, everyone in chat, thank you guys. Thanks for popping by. Look, I know it's a weird stream. I didn't really let anybody know I was gonna come back. So it is what it is. Anyway, Feynman said something about, if you can't explain it to a layman, you do not understand it. Is there a best of both worlds where even the children can practice? What do you mean children? What do you mean children? Like, you know, I feel like there's no reason you can't give a 5th grader a paper and have them understand it, right? There's no reason in my mind. I think that, you know, when you're at the age of 10 or 11, obviously you can't give them like a nature paper or something, but you could give them a review article, and in principle they should be able to get through it. I was able to get through it in junior high, and that was just because I stumbled upon it while I was like Googling stuff, you know. Yeah, Google existed when I was in junior high, right? Am I misremembering? Man, am I that old? I mean, I am pretty old. At this point, I'm pretty old. Anyway, it is what it is. Here's what I want to do today, guys. I've kind of talked about what I want to do, like where I'm going with research stuff, and like, you know, for this particular paper, I've got multiple like offshoot papers that I want to publish. There's like 7 of them, right? That I've kind of come up with. The first of which is just the general paper, like Composable Function Systems as a General Purpose Binary Framework, right? When this one's out, I then have multiple other papers, like on real-time real-time visualizations, which this can kind of do real-time, but I haven't piked it into Vulkan, so I think having a separate one for real-time, and really like using it on a Gaussian splatting example as people would typically see it, is one idea that I want to go for. I have some ideas for kind of putting it into a physical simulation. I have other ideas about using this with quantum hardware. I've got like a whole bunch of different ideas. So that was just 4 papers that I listed right there. And then I've got other methods that I have envisioned as well for this. So, this is just paper 1. I want to keep working on my own stuff. But here's the thing. I am a research software engineer from MIT that knows GPU computing, and it's I have a lot of hot topics. I know a lot of different areas, and so if you're a researcher who also kind of needs GPU experience, or you have an interesting project that you might want to work with me with, you know what I mean? Like you think you could use my expertise, and just reach out. It could be here in chat. It could be in the YouTube comment section. It could be on Twitch. It could be on Discord. It could be any way you can. Just reach out, and I will. I'll do what I can to engage with that in any way that I see fit. I'm really trying to find like good, interesting research projects. And again, like I said, I really want to build the scene. I want to get as many people as possible involved with the process of doing open research, because it has so many advantages, right? Like, you popularize your research trends so that let's say you're into like some quantum crypto stuff. It makes it so people can now understand quantum crypto by opening it up and trying to explain it to the layman and stuff like this. There's so many advantages to doing it in this way that I just want to promote this process to the best of my abilities, and I'm hoping to kind of collaborate with like different institutions, whether that be universities or any type of different thing. That's my goal. We'll see. Google was invented in 2005. Where was I in 2005? 2005 was 20 years ago. Well, 21. So yeah, it would have been around that time, I think. But are you sure? I distinctly remember having access to the internet and like Googling things before 2005. I feel. How was I Googling before Google? Anyway, it doesn't matter. I'm old. That's the truth. I'm just an old person. There was also another paper that I wanted to get out soon on various different methods that we've been doing in the Julia lab for we have so much stuff that we can do in the GPU ecosystem that Julia has available, and we haven't published any of it, and this is another thing that I've been working on, right? Okay, so lots of stuff to talk about, but I think for today, because this is my first day back streaming, and I just have so many things that could have been Yahoo, Ask Jeeves, maybe. Anyway, look, I have so many things that I want to talk about, but also I need to get back into the process of just streaming and talking and like engaging with the audience and stuff like this. So like, let me do something weird today. And I think actually what I'm going to do, and I know this sounds really stupid, I kind of just want to go on the archive for a bit. I just want to read the papers, look at the papers, see what people are talking about today, and go from there, right? So that's my goal. That's my plan. That's what I'm going to do. I know it's stupid, but like, I've been talking all about like research and stuff and like interesting things that you could do with research and all this kind of stuff. But like the majority of research in my mind, like the most fun experiences I have as a researcher is, it's just reading papers and like engaging with the literature and like finding my way through like interesting rabbit holes and stuff like that. And that for me usually starts on the archive. I just go here and I look at papers and I find stuff that's interesting and I go through it. That's what I do. I wonder if Julia can already do wafer scale engines. I think they can. I'm pretty sure they can. Because wafer scale engines are just like TPUs, right? What's the difference between a wafer scale engine? We talked about this before. Wafer scale engine and TPU. Is there a difference? Sorry. Aren't they the same thing? Or am I stupid? Oh gosh, I don't remember. We can do TPUs. But I imagine we can do wafer scale. I think. I don't know. I really don't know. Sorry about that. The truth is, I'm like quite behind on all my Julia stuff as well. Like as of like November of last year, I kind of just stopped, doing everything. And because of that, I haven't been able to keep up with the Julia stuff that's going on. There's some weird stuff going on in the Julia ecosystem right now. What's your OS and Windows display? Emacs? No, I'm not using Emacs. No, I'm using Arch Linux. And the display manager is OpenBox. I've got my own system or setup. If you go to Discord, there's actually like a pinned message way back on my specific display manager and stuff like this. Yeah, I've just been using it for years. Honestly, I made it when I was like, again, I really remember doing this in junior high, but it might have been the first year of high school. I made this, and I've been using it since then. I've not changed anything about it, just because I made it specifically how I wanted it to be. I got used to it, and then that's it. And TS Jost has his links already, or his clips already. That is typical. By the way, I didn't read it. To Internet, wonderful welcome episode. Hello, people, Leos Labs of back another the. Man, I'm rusty. Let's get through. So, what am I doing? I think the first thing I'm going to do is what I always do, which is just go to computer graphics. So I usually go to computer graphics. Graphics. Oh, just graphics is what I should have done. Graphics. Because usually computer graphics only has like articles when there's a conference going on, which means in the off season, you usually get like just a few papers to go through that may or may not be interesting. And it's usually quite nice to go through, right? The nice thing about computer graphics, as opposed to a lot of the other fields, is that it encompasses a lot of like little things, right? It's got mathematics, it's got physics, it's got AI, it's got GPU engineering, it's got so many different things. And so like as you start like reading like the papers, you start to really get an idea of like what, I don't know, you have a lot of different things that you can look into. It's quite fun. So I'm gonna go ahead and go through these, and we're just gonna see if any of them what is this? Compact Gaussian hair reconstruction with card clustering. Okay, let's just go through, okay? I'm going to do my best to explain like why I find the papers interesting that I'm picking out. And the main thing when you're going through the archive, right? I know a lot of people don't go through the archive that much. Even researchers don't like doing it. But for me, the main thing that I like about going through the archive is reading a headline, right? Realizing that I don't really understand what the headline means and trying to figure out what it means, and then figuring out how from this bit of information that I just got, how I can use this in my own research, like how I could use this to make my own work better, right? That's what I do. So for example, this first paper, What a Comfortable World, Ergonomic Principles Guided Apartment Layout Generation. So first of all, this is an AI paper. Oh, it's for Eurographics. Oh, okay. Wait, let me take a look at this one. I'm so sorry. I'm so sorry. I think I need to move this over here. And then I just want to take a look. What do you mean? So these guys are generating apartment layouts? They're using AI to generate apartment layouts? Am I misreading this? So basically what they're doing is these guys are landlords. So these guys are landlords who are trying to use, I guess they're trying to find the optimal usage of a space such that they can charge the most for it. I'm not really sure what they're trying to do here, but who needs this? So current data-driven floor plan generation models often reproduce. Wait. There's more people doing this? Wait. This isn't just like a one-off paper. Current data-driven floor plan generation methods often reproduce the ergonomic inefficiencies found in real-world training datasets. That's fair, right? So these guys are like, we can pack more people into the room if we AI generate the room. That's what they're saying. Current data-driven floor plans generation methods often reproduce the ergonomic inefficiencies found in real-world training datasets. They're like, look, if we ignore like the things that make rooms like comfortable, we can fit more people into it. To address this, we propose a novel approach that integrates architectural design principles directly into a transformer-based generative process. We formulate differentiable loss functions based on the established architectural standards from literature and optimize room adjacency and proximity. By guiding the model with these ergonomic priors during training, the method produces layouts with significantly improved livability metrics. Okay, so they are going by livability metrics. Comparative evaluations show that our approach outperforms baseline in ergonomic compliance while maintaining high structural validity. So again, lots of things that I'm interested in here. Number one, do we really need like AI to like do feng shui for us? Like that's number one. Like, do we really need AI to like figure out like the optimal layout? It seems here that the idea is that we're given some sort of, I'm not sure what we're given here actually. So like, what are what are we given here? So it looks like, yes. So it looks like we are given some sort of layout of an apartment, and we are trying to find a way to basically set things up such that they maximally utilize the space based on some parameters, right? Whatever those parameters are. I naturally assumed that this would be shoving as many people as possible into a room, which is kind of interesting, I guess. But like, I think what they're actually doing is livability metrics, which basically means like as much open space as available. And actually, you can kind of see why this is interesting. See, look. If you look at their basic, like the basic floor plan here, so theirs versus baseline versus our plan, I don't actually know what these are, right? So living room, master, bathroom, kitchen, study room, second room, balcony. So basically what they have are a bunch of blocks that got to fit into this bigger space in here, right? And theirs clearly has an open walking area and rooms set up in such a way that they are actually accessible, whereas here, they end up clustering the blocks together in such a way that it's difficult to imagine moving from, I don't know what these are, but like master bedroom, normal bedroom, bathroom. Like it's just, in this situation, like you have no access to the balcony. It is what it is, right? Like you can actually see that their plan is just based on this better. And looking at this, you could also imagine this being very useful for like packing, for example. Like, for example, you're given a box and you're asked how to efficiently put stuff into that box, right? Like, you know, you're an Amazon packager, right? And you're given like 5 objects that you have to fit in, right? And the question is, how do you appropriately fit those things in? So this is solving fundamentally that problem, right? Like, how do we fit these blocks into this space such that we can optimally use it based on certain metrics, right? Not like how do we shove as many things as possible into the room, but how do we use the space such that it's the most livable or whatever metric we're looking at, right? So, okay, I can see this as being useful, although I'm very confused as to why it's framed as a, like, ergonomic principles guided apartment layout generation. Like, why are we limiting ourselves to apartment layout generation when we could instead be focusing on like the much more relevant problem of like boxing things up or something. I don't know. I'm interested in this. Actually looks interesting. I'm so stupid. I just spent like 20 minutes talking about this paper. I feel like interactive demos are great for engaging. Wait. I feel like this is unreasonable, but can you make your interactive demo for your paper with web GPU? Many of the coolest computer graphics paper have interactive demo. I can, yeah, in principle, yes. In practice, it's going to be a little bit annoying, but yeah, there's no reason I can't. I feel like interactive demos are great for engaging common people to interact with research. If we ignore physics, we can put more people per square meter. Right. Hey, what's up? I don't know, but I feel like the resulting floor designs are unphysical. Also, a house is not a static thing. Rooms change purpose too. Building inspectors are going to have a headache with AI aligned houses. Yeah. This whole thing is silly. But like, just imagine, like, first of all, like, a couple things about this. So why are we getting AI to do feng shui? That's number one. Number two, surely there's a more like appropriate usage. Okay, wait. I understand it now. The reason this is actually a more complicated problem than the box problem, because the box problem, you're always going to have like a square, a rectangle, or some rectilinear thing. Whereas this, you have like shapes that are not perfectly square. And because of that, it's more difficult to figure out exactly where you're going to put the living spaces. Also, the living spaces are movable. They're changeable. You can change their size and shape. And so because of those reasons as well, it's in a sense harder because you have, like, I think fundamentally what we're trying to do is figure out how to fit as many objects as possible into a box for Amazon, right? But that's a very difficult problem, right? And so instead, we're going to focus on another problem that is difficult in a different way, right? And it's still useful, right? Apartment, this apartment floor plan layout generation has a more difficult problem in that, like, the boxes are not boxes. The outer region, the shell in which you're putting stuff in, they're not fully like the square or rectangular, but the spaces can be modified to some extent. So yeah, I see where this fits in. I see why it's interesting. I don't understand why it's in Eurographics, but it's cool, right? It's cool. Let's extend a fun paper in a fun direction. Cool. So that's number one. We just spent probably 10 minutes talking about one paper, the very first one I saw on the computer graphics today for the archive. And now you can immediately see why I have so much trouble reading the archive. And it is, to me, the most addictive website that exists on the planet, because I've only gone through one paper and I spent, 10 minutes talking about that, right? And now we have so many more papers to go through. And all of this, is it's just people who have, in their mind, push the boundary of human knowledge in some way, and they want to share it. That's what this is. It's just the coolest thing ever, right? Like when I talk to PhD students, or people who want to do a PhD, or they're asking whether they want to do a PhD, I always tell them go to the archive, right? I tell them go to the archive, and I say just click around. Click around, and if you like the papers that you see, go to that field, right? Like just go to, physics new, go to mathematics new, and see what papers are there. And if you find papers that you vibe with, that you're like, oh, this is really cool, I want to read more, go down that route, right? Like, for me, it was computational physics when I was growing up, when I started my PhD, and I've slowly started shifting towards graphics, And the other nice thing about graphics is if I just hone in, if I only focus on graphics, I can usually get through them in a day. Because otherwise I end up spending way too much time reading too many stupid papers. That's just how it goes, you know? Okay, so let's keep going. We are not going to get through this. So investigating performance and practices with univariate distribution charts. What's a univariate distribution chart? I should know this and I don't. What is it? Does anybody know? What is a univariate distribution chart? Why am I so dumb? I'm so stupid. I need to find a better way to do this. I should just open the whole thing up in Firefox. That's what I'm going to do. I'm going to open the whole thing up in Firefox. Give me a second. Yank, and open up a new Firefox tab. This way the PDFs can open up with the website. So Control V. I'm an idiot. I could just do archive again. Why am I so stupid? Archive dot .org. Go down to graphics. Where are we? Graphics. There we go. All right, so this is where we were. The font's a little bit different. I don't like the font as much, but who cares? Univariate, one variable. Oh, I should know that. But distribution charts. What's distribution charts mean? I'm just gonna grab the PDF. Okay. So range of charts with different. Oh, this is it. This is what it is. 4 charts used in the study. Performance practices with univariate. So what is interesting about this? Should I be able to understand it immediately? Okay, I shouldn't have clicked on this one. I don't really know what's going on. A range of charts with different strengths and weaknesses exists to support the visual analysis of univariate distributions, with a limited understanding of which chart best supports which tasks and users, and how practitioners use charts. We categorize the available charts for univariate distributions in 4 groups and present the results of mixed method comparisons. Our analysis reveals differences between charts in task accuracy, common misunderstandings, and okay. So this paper is basically saying, like, the way in which you present data affects how people interpret that data. Totally fair. And I guess it's basically saying, like, different charts will... interviews with 5 of the visualization practitioners fully reveal that charts widely preferred by general audiences, such as histograms, are commonly used in scientific domains such as box plots, are not inherently the most effective for all tasks. Okay, quite obvious, I would feel. I feel like most people would be able to... most people understand different plotting methods present data in different ways, and by presenting data in different ways, you're going to interpret it differently. I don't understand why this is a 2026 paper. What did they do? But fine, we gotta move on. But I don't really understand what's like the novel thing about that. All right, let's keep going. So physics-based motion tracking of contact-rich interacting characters. This feels like a Pixar paper from 2007. That's what this feels like. Motion tracking has been an important technique for imitating human-like movement for large-scale data sets. So my feeling here is that our method learns... Okay. So the reason this is potentially interesting, or I thought it was potentially interesting, is because motion tracking kind of sucks. I mean, it's fine, but it's very difficult to do properly. Like, if you've ever watched, like, I don't know, VTubers or whatever, and they do their 3D motion tracking thing for their songs or whatever, you'll know that the tracking is not very good. So I was hoping that this would be more like... yeah, I think this is solving that problem. Like, if you have 2 VTubers in a room together who are hugging... Okay, that was a stupid... You know what I'm talking about. Like whatever, if you're watching... Oh, who are the 2? There's the 2... What are they called? The Autofisters? Am I stupid? Oh, I shouldn't have said that. It's Gigi and Cece from HoloLive. I have been online way too much for the past few months. They tend to interact with each other, and this is probably a situation where they're trying to make it so the models don't interact with each other. That's kind of what we're talking about. Oh my goodness. I know way too much about HoloLive. This is 2 minute papers material. Yeah, it's definitely 2 minutes paper material. I hope he's been putting out more like graphic stuff and less AI stuff recently. But this is, you know, there's obviously a lot of intersection between AI and graphics. That's totally fair. Reading papers as per usual. I see all I'm doing right now. Look, I'm getting back into the swing of things, guys. We will not be reading papers only on the stream. We'll be doing other stuff, I promise. But just today, I wanted to read some papers. Okay, we seeing enough non-reference perceptual resolution selection for power-efficient client-side rendering. Okay, I mean, I'm not sure what this is about either, but it looks like perceptual resolution selection. What I just want to look at. Just give me one image so I can tell what you're talking about. What is this talking about? Client-side drivers. Okay, look. Basically, they're trying to move stuff on the client side. That's okay. Gaussian animate, reconstruct, and rig animatable categories with a level of dynamics. So first of all, this is quite cool because like we were talking about Gaussian splatting before, right? And we are talking about how the splatting works and all this kind of stuff and how it's essentially a point cloud. So I think the interesting thing about this is applying a mesh to essentially a point cloud so that you can move it and render it and move in a way you would typically do for a mesh, I think. Which makes it quite cool because this is one of the things that's very difficult to do. And actually, if I'm being honest, this is exactly what it looks like. And it seems like this is also one of the things that you can do with my method. Like the paper that I'm writing, this is one of the proposed strategies to use my method in the wild. It's to take a point cloud that is essentially used for Gaussian splatting and to more accurately rig it as you would in this sense. I should probably do that as one of the examples in the paper. Something like this would be nice. But I'm already showcasing that. I don't think it's actually that relevant. Yeah, I don't think it's that relevant to show the rigging itself, as long as I show the equations used for animations. He's doing more fluid dynamics material recently, but some interesting AI stuff from DeepSeek. There was his automatic subtitles for live streams. He's a little fast with his words. Here's the thing. If you're watching on YouTube, you can slow me down. If I'm too quick, you can slow me down. That is the advantage of YouTube. But I do understand, again, this is my first stream back in a while, and I get that a lot. A lot of people say that I speak too quickly. I get it. I get too excited about this kind of stuff. So I'll try to slow it down and make it so people can understand it a bit better. So, fit a large-scale data set for fit-aware virtual try-on. So this is one thing that a lot of people have been focusing on in the computer graphics space for a long time. It's like the ability to walk up to a mirror, or essentially no, it is a mirror. Like you go up to whatever, I don't know, Victoria's Secret. Okay, not Victoria's Secret. You go up to, probably not Victoria's Secret. It's probably the worst example. Any clothes shop. You go up to any clothes shop, they have a mirror. You walk up to the mirror and you say, I want to see what I look like in this outfit, right? And so you hold up your, I don't know why I said Victoria's Secret. There's a lingerie store. You would not pick up a lingerie like item and be like, I wonder what I look like in this. But like a dress or something. You put this in front of the mirror and you say, what would I look like in this? And then it somehow generates you in real time moving around and showing what it would look like on your person, right? It's a big thing. A lot of people have been focusing on it because it clearly has a lot of market potential. So it's one of those things that like people care about, and I don't personally care about it, but it encompasses a lot of the problems that you have in computer graphics, right? Like cloth simulations are very difficult a lot of the time. So you have to do like really good cloth modeling, and you have to do it in real time, and you have to make sure, that the meshes are imported in the right way. There's just so many different things that make this a really good computer graphics problem, even if like the actual concept is not super interesting for like everybody. It's interesting enough that there's market potential, and it's like interesting from a computer graphics perspective because there's just a lot of little problems that you have to solve to make this work. Image-guided geometric stylization of 3D meshes. I think, if I'm understanding this correctly, they are AI generating a 3D mesh based on what it looks like. Okay, my guess is that they are taking an image. It's in multiple images, and they are trying to take the point cloud based on some like neural radiance field, something that would be Gaussian splatted, and they're trying to turn this into a mesh. I think is what they're trying to do. The reason they're probably doing this is because meshes like basically the entire graphics pipeline is based on meshing, and so to ignore that or to ignore meshing is to use some other rendering method that is not typical for you via Vulkan or OpenGL or something like this. So that's like the core problem with splatting. It doesn't use traditional techniques. So they're probably trying to take splatting and force it into a traditional workflow is probably what they're trying to do. Our method enables stylization of 3D meshes driven by image. Oh, it's different than what I thought. The target stylized meshes retain the core structure and semantics of the input mesh while incorporating internal geometry derived from the style reference. No, it's just AI generating. It's basically manipulating a mesh. It's like stylized. What is it? Stylized transfer of. There's a word for it. Like if you draw a picture and you want that picture to look like Van Gogh did it, they're doing the same thing but for meshes. I swear I've read about this before. Like I don't feel like this is new enough. So I'm very interested to see what they've done to make this new. Or maybe I'm just misremembering. Maybe it is new and I just completely forgot about it. Imagine a booth at the store and a well-engineered 3D splat booth. I think the thing is, I think splatting it has its limitations, right? And a lot of people are trying to work around those limitations, right? One of those limitations is that you basically need to have the entire space imaged beforehand. Like you have to have it all done a priori, which means it's very difficult to do, like to have some person walk into a scene and just be immediately splat into it and all that kind of stuff. There are ways around this. People are working on it, but I don't think it's impossible to do this in the near future. It's just, where it's what people are doing. Let me see. What do we have here? It sounds fake. You're the right amount of, you can speed it back up again. There's an extension that lets you slow down and speed up the with a mouse wheel. I wish there was automatic subtitles, but then it wouldn't be live anymore. What do you want me to do? I can speak slowly. Do you guys want me to speak slowly? What can I do to speak slower? I could get a musical instrument, and the whole stream I do with a musical instrument, and that will force some of my brain speed to be focused on the instrument, and then I won't be able to talk as fast, right? That would work. Yeah? Do you want me to get an instrument out? I can get an instrument out. No, but it is a problem. I know I speak too quickly. It is what it is. What was the thing I was going to say? Drink less caffeine. I can't drink caffeine because of my heart, man. You can speed up and back down. Too excited. Don't understand. A fashion company funded research into better cloth simulation. I presume it's for better digital fashion and advertisement. This is corridor digital material. I think they did make an AI assisted stylization on real footage. Yeah, look, I think the corridor crew is doing a good job. So what am I gonna do? Well, okay, look, I could probably drink caffeine. Maybe I shouldn't have. I'm sorry. I could probably drink caffeine. I just stay away from it. Because anything that could potentially cause heart palpitations, I need to stay away from. Good. So geometry, motion, alternating refinement for articulated object modeling with Gaussian splatting. What a title. Geometry, motion, alternating refinement for articulated object modeling with Gaussian splatting. I can't even grok the title, man. What is this? High fidelity interactive digital assets are essential for embodied intelligence and robotic interaction. What is this? What are we looking at here? Geometry, motion, alternating refinement for articulated object modeling with Gaussian splatting. So what are we looking at? Obviously, I think it's just for initialization. Geometry, motion. Oh, okay. I think I understand. They want to get an image of a desk, obviously, and then with the image of the desk, what they're going to try to do is figure out how all the little pieces move together in that desk, so that they can then move the desk pieces around in their artificial intelligence software in their brain, without having to physically move it around. I think is the idea. They want to look at a box, look at a desk, look at something, and from that picture of the box, they want to figure out what can and cannot move. I guess that's my best guess here. So this is making Gaussian splat animation, right? I like your talking speed. I have to watch YouTube videos at 1.5 or 2x because everything's so slow. I'm the same way. When it comes to specifically Twitch streams, I have so many content creators that I will watch, right? So many content creators that I'll watch, and I only watch them at 2 times speed, right? And so then I watch them on Twitch, and all of a sudden I can't follow them anymore. They're too slow for me, right? And so I don't know how to engage sometimes with people's content because I'm so used to them speaking so quickly that when they're not speaking quickly, I don't know what to do. So that's kind of how it is. Okay, so good news. We have gotten through all of the graphics papers for today. Yay! Woo! Yeah! I feel like I walked in a lab discussion between top scientists. I'm so lost. Here's the thing. Let me just talk about something. When I was in junior high and I was reading papers for the first time, what papers were I reading? I was reading papers on... Okay. I'm going to have to say something here, and you guys are going to... Please don't look at me as... What I'm going to say next is going to change your perspective on who I am as a person, okay? And I need you to just take a step back and just... this is a safe space. I'm going to say what I'm going to say, okay? When I was in junior high or early high school, the papers I was reading were on machine learning. That's what I was reading. Now, let me tell you what the hot topics were in machine learning at the time. The exact same topics that are being covered now. The exact same. This is the reason why I get so annoyed at the AI stuff that's been happening recently, because everyone's talking about it like it's a new, fundamentally interesting technology. It's no, but from the research perspective, from the papers that I've been reading, they have not changed. They're the same thing that I've been reading for like 20 years now. So like, why? Gosh, that was embarrassing. Jesus. So like, why? Anyway, I don't want to get into this too much, but yes, the papers that got me into research to begin with were AI papers. That's what it was. I was reading AI papers. And in particular, I was very interested in the creation of a biologically inspired neural architecture, right? One of the first projects I had on GitHub was called BIAS, the Biologically Inspired Architecture Simulator, where I would basically replicate IBM's True North chip, which was, trying to do the same thing, except in analog electronics. It was a really big, I was really excited for it at the time. I was going to focus on it for my PhD, but I didn't. I instead did graphics stuff and quantum simulations and stuff. But I still do kind of want to go back to it because I think it's interesting. But now I feel like it's probably old news. I feel like people have probably already done it. Anyway, long story short, the reason I brought this up when Reader Music said I'm so lost is because that's what it's like to do research. It's the feeling of constantly being out of your depth and trying to crawl your way back to understanding what's happening, right? The first papers I read, I obviously understood none of it. They were talking about glial cells and I don't know, action potentials and all this kind of stuff that I knew nothing about, absolutely nothing about, right? But there were a couple phrases in there that would keep me going, right? And those phrases were things like, this particular object, this idea is an object of further study, right? When people would kind of point out that there were still things to do in science, right? There were still things to do with research. There were still things to do to make this study even better, right? That would make me very excited because it would make me realize that these top scientists who are doing things that are astounding to me, actually don't know everything, and they are equally, maybe not equally, but they are not as knowledgeable as they don't know everything, and I as a person can get to the point where I'm going to be able to understand everything, the same way they got to the point where they could understand everything, and then I can push in the same way that they're pushing now, and that was the most motivating thing for me ever. I think in my entire life, reading the phrase that this is an object for future study or this is an area for future development was so incredibly motivating for me as a kid that it might be the single most motivating phrase for me as a person, right? And so that's it. That's the reason I'm doing research, is because when I was reading, Ernst Niedermeyer's Electroencephalography, Basic Principles, Clinical Applications, and Related Studies when I was 13, when I was reading this book, at the end of every chapter, he would say, these are all the areas of future development that need to happen for us to better understand this weird brainwave thing, and that's it. That was the thing that got me hooked, realizing that there was more to do and that science wasn't this monolith or wasn't this thing where we have all our ducks in a row and we understand everything. We don't. And that's the beauty of it, that we can learn more. And that was a rant. Sorry about that. Nice explanation. What do we have here? Hey, what's up, Akshunya? Kinda. Back then we focused on analytical methods, maybe transformers. Now everyone is gung-ho on generative models. Well, it's not. The fact is that we did not... At the time, right, we were focused on different things, right? We were, obviously, as of 10 years ago, right, we were mainly focused on, reinforcement learning methods and stuff like this. From my perspective, this is the thing that I really felt was a big deal 10 years ago. And we were not focused on the deep learning stuff. We were kind of starting to focus on the deep learning stuff because the hardware just hadn't reached a point where this stuff was viable. But the concepts were there, and they've been there for 20, 30 years, right? Swarming stuff, yeah. I mean, who doesn't remember a good Evo Devo, lube? Good rant, 10 out of 10. Rant if I've ever seen one. Well, good. I'm glad some people like Ramboleos. I hope you're fine and you can handle your health condition well. I got a quick question. I was reading up on flow matching, and it reminded me a lot of your approach. I don't know about flow matching. Let me look it up. And this is why I love streaming, because somebody is going to give me some idea that I hadn't thought about before that is actually very relevant to the stuff that I'm doing right now. Via PDF. We introduced a new paradigm for generative modeling built on continuous normalizing flows. Oh, okay, right. So actually, the initial paper that I'm writing right now is not going to be related to this, I don't think. But one of the future papers I was going to publish on my method, in relating my method back to physical simulations, I think is very much similar to this. And so actually, I think this is quite relevant. Thanks for bringing it up. I appreciate that. My friends prefer calling those info dumps. Well, I call them rants, or rambles, I guess. I'm interested in this. Let me see what they're doing. What's up with the images? Unconditional ImageNet 128 CNF. What is this? Allowing us to train CNFs at unprecedented scale. Specifically, we present the notion of flow matching, a simulation-free approach for training continuous normal flows based on regressing vector fields on fixed conditional probability paths. Actually, quite good, this one. Thank you for giving me this paper. I've been trying to find a way to use, basically, okay. CUDA's got this package out there for vector search, right? And I just haven't found a good way to use this type of technology at all in my research. But having a way to connect kind of similar stuff that I'm doing to vector search or something like this might actually be useful here. Flow matching is compatible with a general family of Gaussian probability paths for transforming between noise and data samples, which assumes existing diffusion paths as specific instances. Interestingly, we find that employing what are FMs? Flow matching with diffusion paths results in a more robust and stable alternative for training diffusion models. Okay, lots of things here that I need to learn about. I need to learn a lot about this, but it might be useful. It might be useful. Diffusion paths conditional score function. Let's see. It might be useful. What is this that we're looking at here? Oh, here's the diffusion from a Gaussian to a checkerboard. It could be useful. I need to think about it a bit more. The problem is that the method that I've been working with is more like, So I have a problem with a lot of generative AI methods in that like the concepts behind them kind of dissuade users, rather they dissuade developers from writing clean code. What I mean by this is, we have Julia, where we focus a lot on creating good abstractions for people to write code in a very quick and elegant fashion, right? The idea is that you can write code in Julia pretty quickly because it's just, we use abstractions that make it very similar to mathematics, which you already know, right? On the other hand, you have a Claude Code, which can generate a bunch of boilerplate code. Like Julia is like, let's try to minimize the boilerplate code. Whereas if you're using Claude Code a lot, you're kind of like, well, it doesn't matter how much boilerplate code I have to write because Claude's going to deal with that for me, right? So there are two kind of solutions to the same problem that it's fundamentally annoying to write software, right? In the same way, I kind of feel like this is kind of solving the same problem that I'm solving, but in a different workflow than I am aiming for, right? I'm aiming to provide people more control over, it's a similar method is what I'm trying to say. I feel like what I'm trying to do is to give people a better way to symbolically represent the activities that they want to do and the animations that they want to move and to use. Whereas I think this is more, finding a better way to make sure that the stable diffusion pathways are like accurately representing the object that you're trying to draw. You see what I'm saying? It's a different path. So I don't know if it's directly related or not, but we'll see. Also, health-wise, just for the record, I'm still recovering, but I'm recovering in a way that's much better than, like, can I just draw this out? I don't even know if I can. Okay, so look. Let me, do I have a draw? I must have my note. Where is it? It must be somewhere. Okay, here we go. Is this gonna work? Is it plugged in? It's not even plugged in. I'm just stupid. It's not. I can't even theoretically plug it in because. Okay, I'm not gonna do this now. We'll do this later. Look, my point was that there is a weird thing going on health-wise with me. So let's say January, right? So January 6th, Jan 6th to the 16th, I was in the hospital, right? I felt good for a couple weeks after that. Then I started feeling like crap, and I had to go back to the hospital. I'm probably February 1st or something like this. Maybe January 20th or Jan 20th or something, right? And then I had to go back to the hospital on like maybe February 10th, and then I had to go back to the hospital on March 1st or something like this. Basically, what happened was like I would see like an exponential growth, or I'd start feeling better, and then I start to feel like I'd crash again, and then I'd start feeling better again, and I'd crash again, and I'd start feeling better again, and I'd crash again. And so I'm feeling quite good right now, and I'm hoping there's not going to be another crash, but there's probably going to be one more big crash before I'm like fully recovered. But right now I'm okay. My heart rate's under 90. Right now it's 85, so I'm doing great. That's about the best that I can do. No, the music is via Josh Woodward, who has all of his work available on Creative Commons licenses, so it's fine. He specifically says you can use it for this. Okay, flow matching for diffusion, I guess. As I understand, is a determinate alternative for diffusion. Someone from my research project applied flow matching for efficient text-to-speech synthesis some time ago. It seems to work quite well across modalities. Oh, this is cool. You guys are great. This approach is learning a new flow as a deep learning model, and I think your approach is using is the user composing the path. Right, exactly. I think that's a better way to put what I was trying to do. But I think it is related, and I think the question is, how do we relate that, right? Good. Thank you guys so much. Like, this is why I love streaming, for the record. Like, I know I do this all the time, right? Here's the problem, right? There is always going to be someone smarter than me in the chat. Like, always. I don't know how it always happens, but like, you know, back in the day, I was doing like computational optics simulations in C++ or whatever. And there was some guy who was a C++ engineer who'd come in and he'd say, look, you know, you're doing this whole thing wrong. And I'd be like, oh, okay, how am I doing it wrong? And he'd teach me. He'd say, this is how you're doing it wrong. This is what you need to do. And that is fundamentally one of the experiences that you get from streaming that you don't get from just like researching in a hole in a dungeon, you know, far away from everyone else. And the process of opening it up and just being excited about what you're doing. I mean, like I said before, like, you know, research is exciting. It's inherently exciting because everything that you're doing is fundamentally pushing the boundary of human knowledge in a way that has hopefully never been done before. Otherwise, it wouldn't be research, right? And that process of doing something new, everybody wants to do something new. Like that's just we're as humans, I feel like we're wired to want to do new things. And so it's just, this is why I want to see more people doing research. Like, I want it to be that we have like hundreds of science and tech streamers all just showcasing like what they're doing, like fluid simulations, I don't know, biology experiments, whatever it is. I just want to see more people doing like more interesting things, right? Okay. We spent a long time on computer graphics so far. Like I've been here for like 40 minutes and we've only gone through 8 papers. Not even 8 papers. We just looked at 8 papers. When I do this on my own, like I'm much faster, but you know, it is what it is. I'm just gonna kind of read the headlines here and then we're gonna move on to computational physics because I think those are also usually quite interesting. Splats under pressure, exploring performance energy trade-offs in real-time 3D Gaussian splatting under constrained GPU budgets. Man, that's a good paper. Oh, that's a good paper. I have to, let me, sorry. 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 So the reason this is an interesting paper is because Gaussian splatting, like you can do it on your phone, right? You can do it kind of on any device technically, right? And one thing that is interesting is basically finding ways to do, you know, high level graphics, like one of the reasons computer graphics is an interesting field is because it's got to do all your physics simulations. It's got to do all of your, like, you know, real world analyses and stuff like that. But it has to do all of this in such a way that you can do it in real time, right? And that real time restriction for computer graphics makes it so you have to do a lot of interesting tricks to make it so the thing that you're doing is in real time. And further constraining your hardware, and figuring out what the minimal limit is of your hardware that enables you to actually do the technique that you're looking for is also very interesting, right? So that's why this is an interesting paper because, you know, when you have a constrained GPU budget, you know, I'm already interested because, you know, like ultimately, if you want to speed up your simulation for high performance computing or whatever it is you want to do, like the number one way to do that is to minimize your like memory footprint, to limit your GPU budget, right? And then to scale, right? To try to make it as fast as you can on one GPU, and then to find the best way to distribute that to multiple GPUs, right? C++ is too difficult. I always think about these memes about it. Let's see what we got. How to shoot. Oh, yeah. To be fair, it's true. What languages do they have here? Fortran. You shoot yourself in each toe iteratively until you run out of toes. Where's C++ though? You accidentally create a dozen instances of yourself and shoot them all in the foot. Providing emergency medical care is impossible since you can't tell which are bitwise copies and which are just pointing at others and saying that's me over there. So here's the thing about C++. I don't know what people are talking about when they talk about C++. I don't know what language they are referring to when they say C++. Because the thing is, C++ is C, right? Yeah, it's C. You can write C in C++, and many times you are going to be writing C in C++ if you want performance, right? So in many ways, the code that I used to write in C++ for CUDA was basically just C, right? But that's not C++, right? Because C++ also has a whole bunch of metaprogramming tools. It has a whole bunch of, it just has so many different things. You could write C++ in you know, a functional way. You could write C++ in an object-oriented way. You could write C++ in this way and that way. Any way you could imagine writing code, you can write that code in C++. And so when we ask ourselves, is this code idiomatically correct C++ code? There is no such thing, right? Because the way you want to write CUDA code is going to be different than the way you want to write, I don't know, whatever other code, code for, that's my problem with C++. I never know what people are talking about. And I think, maybe I'm wrong, but I feel like, there are so many different strategies to writing proper C++ code that this actually limits your ability to perform, because you're I at least was constantly thinking about what the correct way to write something was, when there was no correct way to write something, because there was no, even the experts couldn't agree, I think they're doing games now with Gaussian splatting as well. Yeah, it's really getting faster. It's really getting quite, my method is Gaussian splatting, yeah, and it can do real time, right? There's no question. But you're specifically saying with neural radiance fields and stuff, which is, another thing entirely, right? There's no reason splatting can't be done in real time, just for the record. It's literally just down to the software, the way in which the software pipeline works. Splatting is in itself relatively quick. It's C with classes, and then the library ecosystem in C++ really changes the language too. Exactly. Rust. I don't know if I really want to talk about Rust, but I can. I don't know much about Rust at all. But I do know that there's a huge group of people who love Rust. And for good reason. There's no reason why you shouldn't love Rust. It's a good language. C++ is 3 different programming languages in a trench coat. That's true. I don't like C++ because it's a consortium that can't say no to new features. That might be kind of what I'm talking about as well. Any chance auto hotkey is on there. There's C++ 98. Right. C is just better than C++. I gotta be honest. I'm gonna put this over in YouTube chat so you guys can see it as well. I have only recently started agreeing with you, Omri. I used to be a C++ guy, but my C++, if I'm being honest, was C with classes. That's what I was doing, right? That's what I was doing, C with classes. I'm not gonna sit here and pretend that I knew everything. That's what I was doing. In fact, you could even argue it's C with vectors, because, C structs are fine, and I kind of use those for most things, But recently, I've been using OpenCL, and I've been doing OpenCL in C, and man, I just love the language. It's so easy. Oh, it's not easy. It's simple, right? And a lot of times when you're dealing with a language, I was dealing with Julia. I've been dealing with Julia for a long time. I love Julia as a language, but it's so complex. It's easy to use, but it's complex. Anybody who does software development knows exactly what I mean when I say that. To make something easy, you must necessarily make the rest of the pipeline complicated, right? You have to, you shove that complexity somewhere, right? And for Julia, all that complexity gets shoved into the compiler, right? And that's fine. It's great. I love it. But going to C, where I get fast compilation speeds, I get fast runtime, I don't have to think about anything. It's man, it's so nice. It's so nice. And I just wish, I don't know. I've got a particular kind of DSL that I'm using for Quibble, which is what I'm using for my research right now. And it's just so nice. I don't have to think about anything. I can choose when the compilation happens. It's so good. It's so good. C++ is basically the English of programming. I understand what you're saying, but I disagree with the fact that to be the English of programming languages, not only would the language have to be needlessly complex, and an amalgamation of everything else, which English is, and C++ are, they're both there, but it also has to be the de facto standard for international relations, because this is how it is. Academia is in English, it's the way I'm communicating right now. You can. I guess C++ is in a sense. Maybe I'm onto you. I agree. Rust is nice, much harder to shoot yourself in the foot, and they're often commonly agreed upon idiomatic ways of doing things. I wish they had Julia on here. No way that they have Julia on here. The way you get, yeah, I'm not gonna get there. That's what I feel with Vulkan. You have to call dozens of API to render a triangle. The thing about Vulkan is, I thought about using Vulkan. I kind of want to use Vulkan, but for my specific workflow, which is a graphics workflow, I don't need Vulkan, right? So what does Vulkan do, right? At the end of the day, you're going to have to do your own SPIR-V compilation and compile your shader and then pass that to Vulkan. All Vulkan does is take in the SPIR-V and run it, right? Well, not really, but I hope you understand what I'm going for here. If you know Vulkan, you'll understand. Basically, you compile your code, and then afterwards, you have your Vulkan code, and then you have your shader code, and you just kind of throw your shader code into Vulkan, right? So there's no process by which that compilation happens in Vulkan. It happens outside of it, right? Which is advantageous because it means that users have the ability to do their compilation when it is necessary, not before, not after. And that's very useful. There's a lot of reasons why you want to do it that way. But And yes, you can parallelize computing on Vulkan. You can, because it's got compute shaders, and these compute shaders are the same as OpenCL kernels or CUDA kernels. They're the same thing. But that was the core problem. I'm doing a graphics visualization right now, but what I found was, for graphics, I'd rather just use OpenCL, because I'm doing a splatting technique, and there's absolutely no reason I need mesh points. I don't need any other type of shader outside of just compute shaders, right? And then I just need to visualize it. So what I'm going to do when I eventually move on to Vulkan is I'm just going to use OpenCL as far as it will take me, which is the majority of the visualization, and then pass the final buffer to Vulkan for the last visualization. And that's it. That's all you have to do. The kernels already run very fast, and they're going to run very fast because OpenCL has some small-scale optimizations for compute that Vulkan doesn't have. And so why wouldn't I just do that? You know? What about the performance? The performance of Vulkan is, for Vulkan compute shaders, is generally on par with OpenCL kernels, although there are some specific optimizations that OpenCL does that Vulkan does not. And the same is true for CUDA. So if you are writing code in a very performant way, and you're like you're overly specifying everything and doing all your loop unrolling and all this kind of stuff in Vulkan, it's going to be roughly the same speed as you would expect from CUDA or OpenCL. How does OpenCL cross-platform compatibility compare to Vulkan? Sorry, my throat's all messed up. OpenCL is, I mean, I can run OpenCL on my phone. Okay, I can run OpenCL on a Mac. I can run OpenCL on anything, right? Give me just 1 second. Sorry. Just 1 second. I got a cough. Sorry, my throat's just kind of messed up. Okay, I can run OpenCL on anything. It is in some ways better than Vulkan, in some ways worse than Vulkan. The thing about it is that Vulkan is where the current, where people are currently pushing. And so because people are currently pushing Vulkan, it makes it so, how do I put this? Like, it's just, you know, you can use OpenCL on a Mac, but it's deprecated. You can use Vulkan on a Mac, but it's not supported at all, except through Molten VK, which is like a community-supported version. You see the difference here? Like, Mac does not support Vulkan. It doesn't support OpenCL, but the current developmental push is towards Molten VK, which is Vulkan, not OpenCL. So that's kind of where it's at. Like, just people are more willingly developing on Vulkan now. The music matched your cough beautifully. Okay, well, great. Okay, let me go ahead and finish this up, because I'm very much like rambling now. It makes sense. So GS Surrogate, deformable Gaussian splatting for parameter space exploration. Why is there so much Gaussian splatting here? I mean, I know why, it's graphics, but just 3 in a row is a bit much. For ensemble simulations. Oh, simulations. Tell me more about simulations. Oh, of course it's NVIDIA. Of course it's NVIDIA. Framework overview, deformable 3D. This is not... The thing about Gaussian splatting that bugs me is that, like, so many people focus so much on the Gaussianness of the splat, they lose the fact that it doesn't matter. Like, you know, like, fundamentally, no one cares about the Gaussian. They care about the splat. That's why people care about using, like, you have some sort of 3D, like, cloud, and you're throwing that cloud onto screen. They don't care how it's splat. It just so happens that we're using Gaussian splatting. This is saying, like, okay, but we can deform the Gaussians. Yeah, but everyone knew you could deform the Gaussian. Like, who cared about the Gaussian? You know, we cared about, like, it could be anything. You could throw bunny rabbits at screen. You know, it doesn't matter. You know, it's just, we've been using Gaussians. That's it. Anyway, what I'm trying to say is, interesting paper, but also, like, we need to move on. Okay, so far, I have to be honest, this Comfortable World, Ergonomic Principles Guided Apartment Layout Generation is probably my favorite paper we've read. Like, it's quite funny. Like, or not funny, it's just like, I did not imagine I would be reading a paper on, like, how to move rooms around in an apartment. It's kind of good. Bunny Rabbit Splatting sounds like a paper that would need ethical approval. I feel like, who is it? Michael Reeves, I think, did a recent video on... dog splatting, so I think we'll do something similar. Fast spatial memory with elastic test time training. It's okay, I'll skip this one. Motion control drone right. Motion control for drone done right. What was wrong with previous motion control? Given a single input image, our method enables controllable interactive motion generation with motion causality reasoning. Left is users can provide active motion to drive scene dynamics forward reasoning, or specify desired passive outcomes trajectory of T-pod, and recovers plausible driving action. Okay. So the idea here is that they move the pod around, and then in principle, the some sort of drone or something would be able to learn to do the same activity. That's pretty cool. I mean, it's good. It's nice. I'm glad people made that. Efficient mono hair. First of all, I missed a couple papers. Efficient mono hair. I don't know why that gets me. Efficient mono hair, fast strand level reconstruction from monocular video via multi-view detection fusion. I mean, they're growing hair. Why do I find this funny? Efficient mono hair. Just mono hair is funny to me. I don't know why. Sorry. Mono hair is funny. Strand level hair geometry reconstruction is a fundamental problem in virtual human modeling. Yeah, so... Yeah, okay. I mean, everyone knows this from Brave, right? Like, you know, the Pixar film Brave had like really, really good hair simulations, right? Pixar has always been known for really good hair simulations and having like strand level hair geometry, like not like usually you do this by creating blocks of hair that you move around, but being able to move strands of hair is more interesting. You have more like clashing of the hair strands together and stuff like this. I don't think it's that. Oh, it's interesting. It's interesting, but I don't see it as. I think that meshes are just the wrong method by which you should be drawing strands of hair. I'm going to be honest. That's what I think. It's because we were just talking about rabbit splatting? Maybe. No, somehow mono hair gets me. DesignNet learning how to draw vector graphics as designers do. I'm going to go on a rant. I'm going to go on a rant, guys. I'm going to go on a rant. And you guys are going to have to listen to this rant. Or not. You can leave. You can leave if you want. But I'm going to rant for just a little bit. Just a little bit. Okay. Anytime we say learning to draw vector graphics as designers do, I get a little bit annoyed because I know what they're doing. They're trying to make it seem like machine learning, like specifically large language models and stuff like this, is somehow synonymous to human learning when it's very, very much different, right? And so like people make this mistake all the time where they're like, oh, we can just have an AI shadow a researcher, and if it shadows the researcher, it's going to learn how to do what the researcher does. But that's not how this works. That's not how it learns. That's not how this process is. You're fundamentally missing the way in which the space works, like the reasoning works. Like you can't just follow a researcher and do what they do. Like it's the same with that automatic poetry generation paper that we saw the other day, right? Like a long time ago now. Like the problem is it could learn some like flourishes based on what an individual can do because it's trying to replicate that style. It's good at style transfer. But fundamentally, if the base is wrong, right? Like if like the way it's learning poetry is this particular way, and the way it's creating, like it's putting words onto the page is done in this particular fashion, like, it's not going to ignore, millions of data points for the one that you're trying to replicate. It's going to use those million of data points to say, this is kind of what I'm looking for, and then add in like words that the other person would use, right? Like that was my problem with the poetry generation. It didn't generate new poems. What it did is it used its knowledge of how to make rhyming couplets, and then it just put in stuff that you would expect from like Whitman or something like that. And so like that's my issue. Whenever people say like, oh, we're going to use AI to learn from scientists so they can do exactly what the scientists do, it's like, well, two things. One, you should never try to replicate a scientist because they've already moved on from what they were doing onto something new. And two, like, that's not how this works. It's been learning how to do like human-like movements or something. You can't just like, you can't teach it fundamentally new things. You can only like, without a huge number of data sets or a huge data set to do that thing. This isn't the best rant, but the real rant is that like, I have been working at MIT for 5 years now. I've been working at MIT for 5 years now as a research software engineer. Research software engineer, that's my title, a research software engineer, right? Now the problem is I don't very much like the software engineering side of things. I like the research side of things because I'm a researcher. That's what I like doing. I like reading papers. I like making papers. I like this type of thing, right? But I'm fine with it because, software engineering is still a good job. And I help researchers out. It's fine. It's fine. I've been okay with it. The direction in which some researchers go, not necessarily at MIT, but also at MIT, is crazy right now. Like, it's because of this large grant that Trump is trying to push through, the Genesis grant. Like, I don't know if you guys have seen this thing, but it's incredible. Like, the Genesis grant, let's see, Department of Energy announces $293 million in funding to support Genesis mission. So basically, here's the idea. The idea is that, like, AI as a thing is cool. So what we're going to do is we're going to make it so every bit of funding that we're giving to science this year has to be about AI. Like that's what they're doing. Everything is basically AI now. And so every one of the labs is trying to find some way in order to like do exactly what they were doing, but frame it as if it were an AI thing, right? That's what everybody's doing right now, so that they can get money off of this grant. And it just kind of sucks because like you'll hear people say stuff about like, oh, I'm going to do this with AI, or I'm going to do that with AI, or we're going to solve this problem with AI. It's like, yeah, but you're missing, it can't do that. It can't do this at all. And you're fundamentally like misunderstanding the technology to say that, because like they had not been doing AI research before. And then they jump in, they see ChatGPT can do this, and they're like, oh, it must be able to do this as well, without the wealth of, without reading the background to understand how the technology fundamentally works. And so it's frustrating. It's so frustrating seeing people go down this rabbit hole without understanding the technology enough to know that they're even going down a rabbit hole to begin with. I'm doing okay. The heart's fine. Again, it's 83. I'm okay. I have to sit down. I'd love to be able to stand up, but I'm not at standing up level at this point. Only 300 mil is kind of small. I was expecting a lot more. I agree with what you're saying, and that's why I also think it's kind of weird that everyone is reframing their entire research like workflow in order to use, in order to force AI into it. That's how you force people to shoehorn AI into everything. I guess that is exactly what they're doing, right? But the reason for it, I understand like I understand kind of why it's happening. The reason why it's happening is because the U.S. economy is in a rough patch right now. Everybody knows it's in a rough patch, right? The economy everywhere is in a rough patch, and the only thing that the stock market sees as potentially useful is AI, and so Trump is trying to make it so AI is the thing that all scientists are doing, because if all scientists are doing AI, kind of like, he's trying to capitalize on them. I shouldn't say he. They are trying to capitalize on the movement, right? I get that. But it's still very frustrating to see that, like, we aren't doing science anymore. We're doing AI. Because, there's the missing middle problem with AI where, like, anyway, I don't want to go in there. We're not going to do any more AI rants. This is my AI rant for today. I don't want to see researchers who don't know anything about AI forcing it into their research plan when it wasn't already there. That's my rant. Is this like faking sketches? Maybe. That's why we're here. I heard of these. It sounds like it's just accelerating the AI into a bubble. Look, we're already in a bubble. I think anybody who says we're not in a bubble, I think they're too far gone. We're definitely in a bubble. The question is what technology is going to come out of this bubble, and whether that technology is fundamentally useful or not. Some of it is, some of it's not, and that's just where we're at. We have to figure out where the cards fall when they fall. So yeah. Surely focusing all investments onto a single thing cannot backfire at all. Yeah, the other thing is, like, some of this is because of Doge, which doesn't exist anymore. So I do kind of wonder, like, if maybe there's going to be another big breakup in the near future. I don't know. It sounds like it's just accelerating into so AI fatigue in every aspect. I mean, there was like a study that was not a study. I read something saying like 80% of it's a crazy statistic that I didn't fully understand, and I don't really understand if I'm even interpreting it correctly, because I just read the headline and then moved on, and I should have read deeper. But it says something like 80% of people who are forced to use AI resist from using AI, right? What kind of chat is this? Is your first time chatting, and you say, I need you, sorry, actually, I'm gay. I'm so sorry, but that is an insane first time chat. Like, that is an insane first time chat, man. I'm so sorry. I don't know where the rant went, but I need you. Sorry, I'm actually gay. Like, is this... It's a good one. Like, I feel like I should, like, do something, time you out or something, but it's also such a good comment. I have to leave it in. It's going to really hurt when the subsidies money faucet dries. So many people are adapted to the cheap cheap LLM high quota paradigm. I see what you're saying, right? Like there are so many developers now who are using LLMs, maybe properly, maybe improperly. Let's not talk about that right now. But it is true that a lot of people are using LLMs to do their boilerplate code. And there's a lot of boilerplate code out there because, like I said before, it's kind of like, some people focus on better paradigms. That was the Julia path. But other people just focus on LLMs to write the boilerplate so that, they don't have to. Like, that's just how life is right now. And I see absolutely no reason why LLMs can't write the boilerplate for you. I mean, why not? Like, who cares about the specific method that you're using for this or that? That's all fine for me. Like, I'm not sitting here saying there's anything wrong with that. But what I am saying is that, like, like, I would prefer if developers had focused on writing better languages with better abstractions, as opposed to letting LLMs take the boilerplate away from you. Like, that to me would be the better approach. The abstractions do allow for LLMs to write cleaner code there, but it's, basically better abstractions reduce technical debt. LLMs generating your code for you will generate technical debt, and you have to question whether the technical debt is warranted in that case, right? This is my mind. And so, like, I agree. We're in that phase where people are using LLMs as if, they are not, like, they're meaningless right now. But, in a while, people are going to have to pay a lot more for it, blah, blah, blah. I understand what you're saying. At least it has more inherent and practical applications, 100% more than crypto or NFTs. The quota thing is developers are actually being told you have to use this amount of tokens. Right. Yeah, this is how it's like in some fields as well. Strong start to their chatter career. Yeah. Smartest people write code gen and macros to write their boilerplate. It's really, really, really tricky to get abstractions right. That's for sure. 100%. Like, this is why Julia has not taken off, right? Because it does have good abstractions in certain areas and bad abstractions in other areas. And people's brains work differently. Some people want to write fully object-oriented code. Some people want to write fully functional code. Some people want to write something in the middle, right? I think most people want to write something in the middle. But, the nice thing you can do in Julia that you can't do in other languages is something like, I can show you. Like, let me just do Julia, and then let's just do using AMD GPU, and then give it a second to precompile. This is the problem with good abstractions. It takes forever to compile. A is going to be equal to rock array of ones of 10, 10, and then I can just very easily add things together by doing a vector add like this. That's something you can't do very easily in other languages, right? So there's things that you can do super easily in Julia that you can't do in other languages. Now, is this impossible to do in another language? No, you can do this in C in 10 lines, right? But in Julia, you can do it in 1 line. Whoa! You see, like, what I'm trying to say is, like, abstractions are nice, but, like, ultimately, what we're trying to do is reduce the burden of thought on developers, right? That's what we're trying to do. And so good abstraction doesn't just reduce the lines of code you're writing. It reduces the mental attention that you spend to each line that you write. And so in my mind, writing 10 lines of C, there's not very much thought that goes into this. I'm just writing and then I'm done. I don't have to think about that. But sometimes writing the exact right function in Julia is a kind of a pain in the butt. You see what I'm saying? And so, like, that's why writing abstractions is so difficult, right? Like, it's very difficult for us to say that this is the correct way to do something. And anyway, this goes back into the C++ argument we were having before, and let's keep going. Have you heard of the Gary's List? It's a vibe-coded personal blog with 300,000 lines of code on Ruby on Rails. I've not. The creator boasts about how he never needs to write code, while his AI spits out way too many lines of code for the blog. Again, this is the thing. Like, if you don't care about a blog, use AI to generate the blog. Like, that's it. Like, I personally think that AI is perfectly useful when you don't care about the thing you're making. It's fine. Who cares? You don't care. So why should I care if you don't care? Like, that's fine. What does ROC stand for? Rock. So that's a good question. I actually don't know. I have no clue. It's just like the underlying, NVIDIA has CUDA. AMD has ROCm. That's what it is. I don't know. I mean, CUDA stands for Compute Unified Device Architecture, but it hasn't stood for that for like 10 years. ROC, I don't know. Random original character. I have no idea. That's just what it is. It's like the underlying thing. I don't know. It's really difficult to get the balance in types of level abstractions just right. 100% get what you mean. Run into it all the time as a user. Gotcha. Yeah, it is very hard, right? Writing a good language is hard. I guess there's always something, the hammer upside down. This is a problem when you try to have a specific behavior. For example, to get good performance, did this get allocated in a GPU or VRAM, etc.? So you need to design it so it can go low level and do the one-liners, right? Well, at the same time, which is hard. That's exactly right. That's why we not only have the ability for users to write like just these one line of codes, but you can also do, write an actual kernel out. So at kernel function the add add A, B, C, and then you just do at index. I'm so not used to this anymore. Global, global, linear, and then IDX is equal to this. A of IDX. Let's just C of IDX is equal to B of IDX plus A of IDX should I have done this in a different order? Yes, I don't care. And now you've got a kernel that does the exact same thing, right? And you might even notice this is not the lowest level of abstraction, right? I could have, for example, I should have specified what A, B, and C, what the types are. You're right. Okay, sorry. There we go. IDX. Thank you for correcting me there. But my point is this. My point is this. Thank you for correcting me. My point is that like you have to provide like the lower level and the higher level, and some people only work on the higher level, and you have to make sure the higher level is still performant. It's a pain. It's a pain. I know it's a pain. Apparently it stands for Radeon Open Compute Platform. That makes sense. That makes sense. Read-only cache. Okay, so what are we doing? Let's get back to the archive for a second. Let me get some water. Never mind. Where's my water? Where did it go? Did you guys take my water? Oh, no, it's over here. Thank you. Everyone heard every single one of my gulps there. That was nice. Okay. Efficient monohair, Cosmo agent, tool, augmented agent for closed loop optimization. I'm just not interested. I'm not interested in anything to do with agents. I'm moving on. Neural assisted impulses. I feel drunk right now. Neural assistive impulses. I misread that as assisted. Synthesizing exaggerated motions for physics-based characters. Okay, when I read neural assisted impulses, I really genuinely thought, like, you got some drunk guy. Okay, you got some drunk guy. He texts ChatGPT. He's like, hey, man, I don't know what to do. Should I ask this girl out? And the agent's like, yo, I got you. I got you so much. Here's what you got to do. Like, I thought it was like the psychological like phenomenon by which, you know, neural agents allow for people to do things that they weren't otherwise able to do, give people courage or something. This is different, and honestly, I'm happy it's different, because I was interested in the paper about, you know, drunk texting, but I think this is probably a better one. Our method enables the reproduction of physics-defying anime. Combat skills in a standard physics engine. The sequence illustrates a dashing arrow combat maneuver featuring instantaneous ground acceleration. Cool, actually, kind of cool. Here's why that's cool. If they learned from anime, this is quite cool. And the reason that's quite cool is because anime is going to be a series of 2D images from different perspectives, right? Of what a character should look like. Taking those 2D images and reconstructing it into a 3D scene is kind of like what you do with Gaussian splatting. Doing that on anime, I don't think has been done before. And then figuring out how to turn that into some sort of a rigged object to move around is also interesting. I don't think that's what they've done. I'm not entirely sure what they did. Or what they're learning from. But like that concept of taking anime, turning this into some sort of 3D scene from the anime, which again, because it's drawn in 2D, it's kind of hard to turn that into a 3D render to begin with. There's a lot of like little interesting bits that you could do there, you know? So yeah, that could be cool. Okay, let's keep going because I have spent too long on this. Real-time neural 6-way light maps. Why 6? Okay, why am I looking at every paper? Why am I looking at every single paper? It's fine, I don't have to read all of them. I don't have to read all of them. Why is this in this format? This is a SIGGRAPH format, or this is in a TOG, transactions on graphics format, which means 2 frames of a chimney smoke, example rendered with rotating camera direction in Unreal Engine. Oh, okay. Light speed. This isn't that light speed, right? Am I wrong? Light speed company. Am I wrong here? No, it's not this light speed. No, I'm thinking about... No. You guys are all wrong. You guys are wrong. Where was the paper? Lightspeed China. Is that Lightspeed the animation? I'm dumb. Is it this one? Wait. It can't be this one, right? Oh no, this is a different one than what I thought it was. Okay, that's okay. It is probably this company, but it's not the one I thought it was. What do they make? PUBG? Oh, okay. Fine. I guess they're relatively known as a company. I was thinking they were the ones that made these short films on YouTube that I'm quite used to watching. So, combat Gaussian hair reconstruction. Card clustering? What's card clustering? Guys, you don't understand. You don't understand my problem with the archive. If I go to YouTube if I go to YouTube, I'm basically never clickbaited on YouTube. Like never. Like I hit the mic. I'm so sorry, guys. I'm so sorry. That was a mistake. That was my mistake that you guys all had to suffer through, and I'm so sorry about that. I hit the mic. It made a weird noise. You guys are just gonna have to deal with that and move on from that. Okay? Look, I'm so sorry. I'm so sorry. I didn't mean to do that. It was an accident. My point is. My point is that, like, when I go to YouTube, I'm basically never clickbaited based on a YouTube thumbnail or title. I'm just not. It's not something that I'm very often, I do very often. I'm sorry. Was it actually bad? It was probably really bad. I'm so sorry. It felt like a hard hit. I'm so sorry. But when it comes to like paper titles, man, I am almost always, you give me any title and I will immediately be like, ooh, actually, I could use this for this reason. Like immediately my brain is like, oh, I'd love to see this in action. You know, I can never get through a paper. Tracker splat explaining point tracking for fast and robust dynamic 3D Gaussian. These are great. Like streaming real-time rendered scenes. Oh, hey, look at that. Look at that. Here's our real-time Gaussian splatting paper. Streaming real-time rendered scenes with as 3D Gaussian splatting. Okay, yo, this is what we're looking for. Talking about using anime to create Gaussian splatted images. Okay, look. We got to keep going. I spent way too much time on the computer graphics side. Let's go back to the archive.org and let me go to computational physics a bit here, because I also usually like to browse computational physics. Yeah, this is my problem with the archive. I said it before, and I'm going to say it again. This is genuinely the most addictive website for me. Like, period. That's it. That's what it is. I for some reason, I cannot explain why. I'm just addicted to this. Like, I have so many papers here that I want to read, and I cannot wait to go to them, right? And then I have like 20 papers that I found just in today because I've just gone to the archive, and now I don't know what to do because I can't read all of them, you know? It's just too much. It's too much. It's too much. Okay, I want to do one more thing. Sometimes, and I know this is stupid, I want to go to popular physics. I basically never go here, but I wanted to see if there was someone talking about the Artemis 2, and it doesn't look like there are. The planetary cost of AI acceleration, part 2, the 10th planetary boundary and 6.5-year countdown. This is a fantasy novel. That's what this is. This is a fantasy novel posted on the archive. I'm positive that's what this is. It is... that is what this is. This is a fantasy novel, not even science fiction. The planetary cost of AI acceleration, part 2. What is this? Yeah, okay, I need to not be on the archive. Part 2. Ask ChatGPT to give you an executive summary of the papers. What I actually want, I want a YouTube-like algorithm. That's what I want. I want a YouTube-like algorithm to like. To give me the papers that I know I'm going to read. That's what I want. I just want to look at this. The planetary cost of AI acceleration. Oh boy, look at this. This is not even... Look at this. They're using Randall Monroe's, like, XKCD plotter. That's what they're doing. This is the only figure in the entire paper, I'm sure. Okay, there's a couple other figures. But this is not actual data that they're plotting. No way. Oh, man. Who wrote this? William Zhu. It's addictive, but like I can't code while reading. There should be infinite scrolling, but for papers, like someone made for Wikipedia. Yeah. The Wikipedia app genuinely stun-locked me for weeks. Like the Wikipedia app on my phone, I couldn't help but like look at it. It would be insane. It would be nice to have basically a better version of Alpha. What am I doing with my life? Should I know Alpha? I should. I don't know this one. In place. Should I know this one? What is Alpha Kiv? I've always just been using the archive, and I've missed out on. Are these like the most popular papers for today? Is that what this is? Like it's. Is this what I want? Is this what I've been dreaming of my entire life? LLM search interface in the archive. Well, but see, they've got likes, so this must be like a Reddit for... I mean, I guess that's what I want. I want people to have a comment section with each archive paper. They kind of do with email. These are trending papers. Elm search. I just, the thing about, someone mentioned this, and they said, ask ChatGPT to give you an executive summary of papers. But here's the thing. Papers already have executive summaries. They're called abstracts, and they're at the start of every paper. So I've never really understood why you actually want to use AI to read a paper for you, because it's kind of already there in the abstract, right? And maybe I'm just like the boomer in the room here. I don't understand it. It has comments. Where are the comments? GitHub stars, resources. Can I just go here? I want to see the comments. I can highlight. Oh, hey, that's actually kind of nice. This might actually be a useful tool. I mean, sure, it's addictive. Oh, wait. There's probably not enough volume on most archive papers to run a YouTube-like algorithm. Yeah, this is true, right? So here's the thing. There is a new job opportunity for anybody who's looking for it. There's a new job available that was recently listed, and it is the archive CEO. So, the archive is separating from Cornell University. I'm sorry, I got a cough again. I'm so sorry. Okay, so the archive is separating from Cornell University and is hiring a CEO who will be paid roughly $300,000 per year. After decades of productive partnership with Cornell University and with support from the Simons Foundation, the archive is establishing itself as an independent nonprofit organization. I will tell you, I've been gone for months. I've been gone since the start of this year. I've been gone since the end of last year. I've been gone for a while, right? And, you know, there's a lot of stuff that happened in the past 4 months, but this to me was the only one that I was like, wow, that is a big deal. Holy crap. Okay, I understand there were bigger deals that happened, but this was genuinely shocking to me. Genuinely shocking to me. How do they generate income? Do they plan to roll out ads? Well, the archive is such a useful piece of technology, a useful website, that they get a lot from donations. It's like, you know, Blender, for example. They don't have ads, but people donate to them, right? It's the same thing. How do they generate income? Do they plan to roll out ads? Imagine the archive with ad. I want an algorithm that maximizes read time. I actually do want an algorithm that maximizes read time, but I don't want the ads. Okay. But yeah, so the thing that was interesting about this, that I was very surprised about, is this. Archive employees volunteer and serve more than 5 million monthly users and have delivered 3.2 billion downloads to date. They only get 5 million monthly users? That's what we're talking about, 5 million monthly users. That's what they get. Is that not low? That feels low to me. For literally one of the most addictive websites I've ever been on, to have only 5 million monthly users is crazy. You go to my YouTube channel, I have videos with over 5 million. Is that true? I don't want to say something that's false. What's on my channel? Your channel. Oh, hello, me. I have popular... I have 5.3 million views. So I have this one video is the archive's monthly user base, right? That's what it is. Open up the API and someone probably will code an algorithm for it. Yeah, I feel like it's not so hard just to do a crawler on the archive. Okay, I'm gonna look at a couple more like archive things, and then probably should close it up because I don't want to do it too long of the stream today. All right. You're right, Loco Padre. You said something that kind of hits the nail on the head. You know, you have to understand that people on the frontier of knowledge, of the knowledge boundary, are only a fraction, and most normies have never seen a paper. You're right. You're completely right about that. But it's just, it does kind of hurt me a little bit. Like, you know, how do I put this? Sorry, I felt like weird lighting everywhere. You can't see it. I felt like lighting right here, and it's battery powered, and it's kind of like dying, and I didn't know what to do about it. Okay, it's fine. Maybe I need to lower this, because I look quite bright, I feel. Is that better? Maybe a little bit better. Yeah, that looks more natural, right? Yeah, I felt like I was glowing before. Was I glowing before? That's where I was before. I feel very bright. I think that's fine. Sorry. Okay, look. I personally feel that everybody should read papers. I think it's fun. I think it's enjoyable. It's the most enjoyable, like the most entertaining thing that I can do is read a paper. Like that's it. That's in my mind, that's it. But I understand that I'm in the minority here and that most people are not that way. Most scientists are not that way. And like part of the thing that I've realized I want to do is just encourage more people to do research, like to push the boundary of human knowledge and to get onto that boundary and just, you know, read papers, enjoy the process, right? Like I said this before, but if people watch a Minecraft stream, they'll watch a research stream. Research is more interesting, you know? Like, that's my brain, anyway. There are a few third-party archive tools out there, so it's possible. I guess the challenge is to get enough active users for the recommendation algorithm to be useful. Beyond the paper similarity features many sites already have. Maybe make it darker, get a Sith hoodie, and put out the caption "Unlimited Papers." Hey, what's up, Amira? Back in my days, we used Scribd to share papers and the textbook. Yeah, nowadays most papers are open, so you don't really need to use it's usually fine, because most papers are open access now, so you don't really have to worry too much about this anymore. But it used to be a problem getting papers, definitely. Let's see. There's probably not enough volume. Oh, and Hanif brought up an interesting point here, saying that, like, you know, we could do like a subreddit type of thing, and that's totally fine for now. Okay, let me look at this. The Planetary Cost of AI Acceleration, Part 2. The 10th planetary boundary and the 6.5-year countdown. Where are they submitting this paper? You know, when you put it on the archive, there's a general idea. The concept is that you're putting it on the archive, and then you're going to submit it to a journal. What journal is going to accept this? What is this? They have? This is towards using renewable energy in mezcal production. A test set of hybrid. I was hoping for some Artemis 2 stuff, but that's not what they have. Okay, so I want to very quickly go back to the archive, and I want to look at a couple others. The first of which is I just want to take a look at core. I usually always look at core because sometimes they have interesting stuff. Specifically with computer languages, there's usually some interesting stuff there. I sometimes will look at rings in algebra. The other thing is I usually go to physics, and I go just to quantum physics new. And then I will usually look at general physics and computational physics. And there's usually where's plasma? Am I wrong? Yeah, there's plasma. Here we are. I just look at these. These are the ones that I like to look at. So let me go through. So we have computer science. The problem with computer science core is that you have just way too many papers to get through in a day. I wish I could just get through all of them, but there's too many. There's way too many here. By the way, I think I need to increase the bit rate on my stream really quick, because I feel like let's see, file. What was settings? Output. Where are we at? Output mode, advanced. No, the bitrate should be fine. Should be fine. All right, we're okay. Okay. Computer bottleneck, distance between percent homology. This is a problem. I can't go through core. I wish I could. There was a day, like during my PhD. No, like immediately after the PhD when I was working at MIT, where the whole day all I did was read through core. That was it. That's what I did. And I can tell you, it's a trip. You know, even at the time, everything was AI, but now it's just gotten to the point that like almost every paper is about AI. Lip kernel. That was different than I thought it would be. Lipschitz bounded convolution neural networks of the distributive layers. I thought this was like lip syncing. I love me a lip syncing paper, but no, it's like actually useful stuff. All right, let's keep going. Quantum physics. I'm going to go to computational physics first. Here's the thing. Astrophysics. Okay, I'm going to be honest. I'm going to be honest here. I think astrophysics papers are one of two things. And look, this is my opinion, and I can be wrong. Astrophysics papers are one of two things. One, they are completely incomprehensible. Like, you will find papers out there that's like talking about like some crazy constellation, not constellation, some scattering of stars that I don't understand, some distribution of stars that I don't understand. I don't understand why we care about that particular planet or that particular thing. And it's like, it's just so much gobbledygook, so much technobabble in some astrophysics papers that I don't feel like I can even understand why we're interested in studying this thing. The other thing is it's either so deep in the trenches of like either, you know, like spectroscopy of trying to understand like one specific star cluster or some sort of like dark matter thing, which I also don't understand. It's going to go very deep into either mathematics or physics territory that I just don't know, or it's going to be so surface level that it feels like I'm reading a sci-fi like proposal. It's one of the two. It's never anything in between that I can just read and enjoy. It's always going to be either too high level or too low level for me. And again, that's my own personal opinion, but I feel like that's kind of how I've been approaching astrophysics before. And I did astrophysics research as an undergraduate, just for the record, you know, I did. But that was a long time ago, a very long time ago. I struggle quite a bit with the way things are phrased in papers. Usually after I get the idea, it's much simpler than how it's written. I understand exactly where you're coming from. Like, for example, let me flip the script here really quick. My wife is a non-native English speaker. She's also a researcher in quantum physics. She is able to read papers in English perfectly fine, but she struggles to read novels in English. And the reason is because the way novels are written, completely different to the way papers are written. Papers, you have to interpret them more like poetry, right? You can't just read them, right? Every sentence means something. The structure matters. And so when you start reading papers as poetry, really thinking about and reasoning about every line as it happens, it becomes much more easy to read, right? And in particular, the style is quite different, right? You can't just read a paragraph in a paper. You've got to really take your time and make sure you have to pause and think with everything in a paper. And even then, it's sometimes hard because, again, like you said, the language is different. Fixing the language is a different problem. Is just reading more and more and more, and eventually you get there. But fixing the pausing to think about every line, that takes a bit more time to figure out. Let's see. Nature blog section. For astrophysics, I'll defer to Dr. Becky for her explanation. A lot of astrophysics papers are some crazy hypothesis with insane math and minimal evidence. The other half is some hot new JWST result disproving a lot of hypotheses. Yeah, this is kind of how I see it as well, as somebody who is not in the field anymore. Again, I did some astrophysics research as an undergraduate, but it's been a long time. Let me see how many papers we got for today. Luckily, only 11. That's great. I have been staying away from computational physics papers recently, and the reason is because it isn't as fun as it used to be, okay? I know I sound like a boomer. I sound like such a boomer, but it's not fun. It's not fun anymore. Like, people took, it used to be computational physics. You'd hop onto the computational physics archive subdomain, and, the papers would be on, mesh generation for hydrocodes that could maybe be used in an FFT situation. And you'd find all this really interesting stuff because people were just trying to figure out how to use a GPU properly, blah, 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 right? There were so many cool things when GPUs came onto the scene. Now it just feels like everything is just they're shoving AI into it, and it just feels bad. It feels bad in a way that I can't describe, because it's all this stuff that we've been working towards, all these algorithms and stuff. Everyone's just kind of AI is slop. AI is always going to be slop. It's slop when it comes to computational physics too, but people are realizing it's kind of fine. It's great for heuristics and this type of stuff, The height of it was during the NVIDIA physics. I actually don't know about the physics stuff for NVIDIA. Detection were topological descriptions of Young's modulus predictions of porous materials. So this is my problem. This is why is another issue I have when it comes to physics papers, right? You've got the computational physics papers, which I can follow, but then you've got the physics papers that do computation, which I can't follow as well. And I think that's my problem. Let me kind of read through these, though, because sometimes there's some good stuff. So reinforcement learning with reputation-based adaptive exploration promotes the evolution of cooperation. Reputation, how is this physics? I don't know how this is physics. Catapult, a CUDA accelerated time stepper for alpha particles using local tricubics. What is an alpha particle? Now you realize how little I know about physics. Our Monte Carlo calculations of alpha particle confinement in stellarators. Stellarators, I should have known. Our GPU implementation is significantly faster than existing parallelized CPU implementations. What year are we? What year are we? No, seriously, what year are we in? We introduced a CUDA accelerated time stepper for alpha particles using local tricubics for use in Monte Carlo calculation of alpha particle confinement in stellarators. What year are we? This sounds like a paper I would have seen in 2014. I'm not, begrudging their code. I'm happy they did it, but this does feel like something I'd read in 2014. The source code is included in the Firm3D Python package. If they're using PyCUDA for this, I don't want to be like that guy. I don't want to be that guy. That's fine. It's fine. But why is this? This doesn't look like. It's fine. This is probably some. It's fine. I need to stop being. They're the speed above our existing CPU implementations is consistently over 5x in various vacuum configurations in both Cartesian and Boozer coordinates. I don't even know what a Boozer coordinate system is. What is Boozer? This enables higher fidelity tracing with a large runtime cost by increasing grid resolution. Yeah, fine. It's fine. I think this is probably an undergraduate level. Maybe I'm misunderstanding. Maybe I'm totally misunderstanding. But it's fine. It's fine. It's good. Happy people did it. Differentiable hybrid force field support, scalable autonomous electrolyte discovery. Again, I don't know why this is physics and not chemistry. The higher dimension of nanophotonics design understanding. Hidden dimension in nanophotonics design. Towards rapid constituent model discovery from multimodal data. Modeling non-Poisson temporal hypergraphs in Markovian node dynamics. Bayesian optimization for mixed variable problems in natural sciences. You can see that my enthusiasm has dropped a bit. Maybe the authors of the mezcal production paper know more about that one. We had a lot of fun breaking and proving AI will never be secure. Oh, for the... Yeah, so I thought it was physics. You're saying it's not for fusion reactors? Wait, I thought it was for fusion. I thought stellarators were always fusion. Wait, maybe I'm misunderstanding. Our GPU implementation is significantly faster than accelerating CPU and handles both equilibrium magnetic fields and shear Alvin waves. We test our implementation on several example accelerators to exhibit both the speed and correctness of our code. The source code is included in the Firm 3D. We want to see GPU code for fusion. Oh, I see. Yeah. That might be right. You might be completely right about that. I remember doing GPU accelerated GPU accelerated plasma simulations as an undergraduate, like we're talking about 12 years ago, I GPU accelerated some of our old Dusty Plasma code. And so I don't know, it is weird for me to see this in 2026 because I kind of thought that was something that people would have already done. But again, I'm happy that people did it, right? Okay, let me just kind of pop out from these guys. Plasma, the thing I love about Plasma is there's nothing going on. It's so my old university, Auburn, where I did my undergraduate, they were known for plasma physics. Like the majority of people who were in the physics department were doing plasma, and it was nice. It's one of those things where like it's kind of easy for undergraduates to get into and have a reasonable level of utility in, right? So that's nice. I would honestly argue that if you're just interested in research but you don't know what kind of research to get into and you have a physics department that's doing plasma physics, yeah, so we were doing, like, we had dusty plasma experiments, we had people who were doing, like, supernova remnant plasma stuff, really all kinds of plasma, to be honest. Like, we had people doing tokamak stuff, we did people doing stellarator stuff, we did all kinds of stuff, to be honest. It was kind of split. I'm not arguing that, like, that's the correct way to do it, but it was kind of nice. Criteria for the economic viability of fusion power plants. All right, let's keep going. That was the fun book. Relativity, a matter of causality. Yep, I didn't figure there'd be anything there. Quantum physics. So this is where quantum physics is big in the archive. Like a lot of people put stuff out in quantum physics. What I like to look for. And quantum physics is huge because you've got the quantum simulations, you've got the quantum information stuff, you've got so much stuff shoved into here. It's really quite difficult to grab like a good headline. What shortcut to an optimal quantum linear system solver. That could be interesting. Let me go back over here and let me see quantum. Where's quantum? Why am I stupid? Yeah, I wish they split it up. I wish I had a better way to go through quantum. I used to do this. Sorry, for my PhD, but I think maybe for today, since we've already been on the archive for a bit, we should probably move on. But it is fun, the quantum papers. I enjoy them. What is this? Oh, this is core. Oh, I'm never gonna get through core. It's impossible. Okay, so we went through the archive for a couple hours today. We went through the archive for quite a few hours today. Fusion reactors have really weird plasma, so I guess it's almost all in strong contact with a boundary. Yeah, that's true. The thing is, I had a couple classes on plasma, and I still don't know if I know anything about tokamaks. We learned about them so much, and I still don't feel like I know it. There's a lot of statistics jargon. Plasma is like dragon. It's unpredictable, and you should never touch it. I like plasma physics. It's fun. Like, I'm sorry. I don't want to be like that guy. I like it. It's fun. I have no other thoughts on it. No other thoughts on it. What time is it? I've been streaming for 2 hours. Again, I don't want to turn this into a very long stream. I kind of just wanted to pop in, say hi. We went through all the computer graphics papers, which is the field I've been most interested in recently. Let's just kind of chat for a bit and then move on. I think of all the papers, I hate to say this, I really genuinely hate to say this, but of the papers that we looked at, the most interesting one was the one that we saw at the start. It was definitely this one. What a comfortable world. It was such a good paper. I just don't, it's just funny. Like, there's so many things that we could do with this, you know? So if I were to use one of these papers and say, like, we have to focus on this and extend a paper, I kind of want to extend this one. This is one I kind of want to read. The other ones, yeah, I want to read. Like, I want to read this one because it sounds crazy to me, you know? I do, genuinely. But it's okay. Streaming real-time rendered scenes as 3D Gaussians. This one, this is the... Oh, yeah, we talked about this multiple times in chat, and it was crazy that it came up. This one I also kind of want to read, just because the representation of Gaussian, like the representation of hair, I know meshes are bad. And so the question is, how do you do that representation? I'm pretty sure some sort of point cloud is better. This is quite interesting, because if you look at it, what they're doing is they're basically creating ribbons and strands that have collision. And then from that, they are... rendering the hair on top of that, right? And so they're kind of mixing different rendering methods, and it's quite cool. Like that's good. This isn't the mono hair. No, this isn't the mono hair. This is CG hair. The mono hair was just funny. Genuinely good. Like I think what they're doing, if I'm understanding this correctly, is they're looking at this. They're using some sort of weird neural radiance field type of thing to get where the hair is. They're turning it into these strands so that they can then better model it in 3D. I think that's kind of what's happening here. It's good. I'm happy to see this. It's nice. I see, what else do we have here? This is good. I don't know. Like, all of these papers are great. Learning from anime, like that's inspired. But of all of the papers, this is the best one, I think. I'm not sure if I would understand that paper without having to read part 1. Hey, Marion, what's up? Some research groups didn't move on to GPU yet, as their realm of knowledge is completely something else. I saw a real bad code from people doing frontier research in their field, and they would not be able to do GPU, as well as AI nowadays. They could. So here's the thing. Well, I misread that, but I understood they could do it with AI. So when it comes to using the GPU, right? Like, there was a situation where a close friend of mine, she's a quantum physicist, right? So she does quantum physics. I think I understand what's happening. These lights are getting gradually darker as they are on. I need better lights up here so that I don't look like I'm just... I look like I'm in shadows right now. Okay, anyway, that's beside the point. I need to fix this so that it's not as dark anymore because it's a little too dark for me. Anyway, long story short, I had a friend who was a quantum physicist, right? She does quantum theory, right? There was a package that she had to work on. And in working on this package, I realized something that she could easily do because she had a Mac was just to add metal support to it, which is, it sounds very complicated. It would ordinarily be very complicated, but because it was in Julia, she could very easily just like basically change all of the values to be float 32 from float 64 and it would work. It was just very small modifications to the code base and it was very easy to get her into it. She could then like do the GPU stuff that she wanted to do. And now she has a much better understanding of software development and even how GPUs work and all this kind of stuff in a way that she didn't have before. And with that in mind, I feel like the thing that's limiting people from writing like good software is a set of abstractions that they can understand and these kind of easy intro problems that will enable them to like jump into the world of GPU computing or whatever and actually use it for their research, right? Like that's it. It has to be somehow useful, right? And so once you give them that intro problem and show that it's not as hard as they thought it was, then it becomes something that they can do, right? To some extent, right? I got a better clickbait title for that. The universe is lazy, always gets the smallest energy level. Plasma is like dragon. I'm copying that paper for later. It looks interesting. Okay, so we've been chatting for a couple hours. I've got a lot of things that I've learned today. The first of which is that my streaming setup needs some modification. That's okay. It should be easy to modify. I will just buy some new lights for the top here and should come in by Monday, which would be my next stream. And yeah, but overall, quite happy today. I kept my heart rate down. Heck, even next stream I could like stand up, which would be great. I'd love to stand. Sorry. I don't know who's watching this or where, you know, if you're watching this on YouTube, I'll be honest, you probably just watched my video saying that I had a heart condition and that I'm like sick and I'm still sick, 100% still sick. But my brain is like slowly starting to work. While I was sick, like in the past month, I was so like my brain just wasn't working half the time. And I had to do, I for some reason, I decided I would continue doing the interviews with NVIDIA. And I got pretty far, but like what ended up happening was during one of the interviews, they eventually rejected me, and the reason they rejected me was because I wasn't answering the questions as they would expect. Just because like they would ask a question and it would take me like 10 seconds to even understand what the question was because my brain was just not functioning. Like it'd be in simple English, like the simplest possible question, and then I'd immediately be like, oh, atomics. Like that's what you have to do. Easy peasy. But like just my brain was not registering what they were asking. And so like just, the heart affects the brain and I was sick. And so they encouraged me to apply again for a different area when I'm not sick. And I might consider that. Do you want a human or a chatbot? Well, my point was that I probably should not have done the interviews when I was in the state where I couldn't think. And I'm now in the state where I feel like my brain's kind of almost working again, which is good. So that's where I'm at. Okay, so I think this is probably a good spot to kind of close stream for the day. We did a lot. I'm actually really happy with like just going through papers, chatting again. It's been a while. I'm going to be streaming next week, and next week I'm going to actually do like research projects. Okay, let me take a step back. I would like to stream again next week. Okay, I would like to make more content again. It depends on how I feel. It's just how it's going to be. Today I feel good. Tomorrow I could crash. We don't know. That's just how it is. So I'm going to do my best. And that's what today was. A 2-hour-long test stream. That's what today was. Is exactly what today was. Just to see how things are going. That's why the title is Test Stream, Please Ignore. That's what it was. But it was a fun stream. I enjoyed it. I enjoyed going through the archive papers in a way I hadn't done before. I might make a video out of it. I've got a good jingle. I've got a good jingle for the intro to like an archive segment. It's good. And again, one last thing I want to say before I kind of close stream for the day. If you're on YouTube or Twitch, wherever you might be, if you are a researcher and you think you could use my help, however that help might be, whether that be, I'm an MIT engineer who knows GPU computing, and that's it. That's my expertise in GPU computing. I kind of know a lot of various different areas. If that seems useful to your project, in whatever way, just reach out to me. I'm trying to find ways to incorporate like research that the community is doing together. I just want to be helpful, and we've got 100,000 subscribers on YouTube. I feel like that's enough for me to be somehow helpful to somebody, and so if you're a researcher, you need me for some reason, you feel like you could use my expertise somehow, just reach out, and I'm going to try to like weave in different research projects together. I mean, it'd be kind of sad if like every day I'm doing the same research project. It'd be nicer if like I could kind of like weave in different projects together. So like maybe one day we're doing graphic stuff, the next day we're doing like I don't know, like some sort of biology thing. Maybe the day after that we do some sort of MD simulation. I don't know. Like the point is, like I'd like to kind of like mix and match things together so that we can just kind of keep the energy up, And I know there's a lot of people here who do a lot of interesting things. And even if you're not necessarily a researcher, if you have something you want to study, you want to look into, I'm also keen to look into that as well. That's kind of where I'm at. So that's it for now. Thank you guys so much for coming in. Again, if you have any questions, comments, concerns, ideas, anything like that, just let me know. But for now, I'm going to go ahead and close off. I'll be back when I feel comfortable coming back. Hopefully next week. We'll see. I got to fix the stream room so it's not as bright anymore or dark anymore, whatever. But, we're getting there. But yeah, we'll see you later. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. I'll see you guys around next time for the next episode of Leos Labs, which will be sometime. I don't know when. Sometime. But I'll see you then. So bye, guys. I gotta say bye to YouTube first. Bye, YouTube. And now for Twitch, if you guys are still here,